Hello and welcome to the NeuroTechSF Hack Night for December 2nd, 2021. We're back after the break and we should have a good episode tonight, hopefully with some guests. Morgan is coordinating some last minute stuff, so I think he'll join us shortly along with the guest soon. And Ryan also hopefully will be joining us, which is great. So should be a full house. In the meantime, you have me. This is it. We can talk about the weather. No, really. I actually, unfortunately, didn't prepare a whole lot for tonight because I thought we were going to dive right into the interview. However, imagine my surprise. So, welcome. Thank you for joining us. At some point soon, this will be a wonderful action-packed call. Well, like I said, until that, we've got what we've got. So, all right, let's talk about other good news. Noise Bridge. Looks like we're going to be able to start hosting events there soon. In addition, we'd like to announce for San Francisco specific stuff. It looks like the weekend of the 11th or the 12th, coming up in a week and change. Some of the members may try to get together locally, which I think is really, really exciting. So we haven't had an in-person meeting since March of 2020. I think it was March 15th. So that was a huge bummer. It looks like we might finally be able to do our first welcome back meeting, and I'm really excited about that. So Hack Night in person at a coffee shop, the way that we started and the way that we seem to be continuing. So I do think that's really cool. There's going to be a announcement posted on the San Francisco meetup so that, people can be aware of it. It's not superficial just because, we don't know the turnout, we don't know whatever, but it would be great for anybody who's in the city and looking to meet up. I mean, it's been a little too long for wonderful reasons, but very, very reasonable reasons. Just if we can get back to it, I think we should, and I think that's definitely a great thing. The other announcement that I thought was interesting this week, just following up on the Meta haptic gloves that we talked about 2 weeks ago, this whole VR stuff, whatever. There has been some interesting rumors really about the VR space in general. So the gloves, of course, there's a startup that, claims Facebook is grabbing their technology, but it actually seems to do with this fluid-based motion feedback system. So it is interesting that this startup is basically saying, hey, look, Facebook copied our tech pretty much whole cloth here. But in that same statement, it was pretty much like, but if you give us enough money, then there's no problems. So I guess we'll find out what exactly happens there, whether money will soothe all wounds or whether they're going to end up in litigation. I can't imagine that that's the route they want to go, and certainly not from the statement that they made. So that was kind of interesting, just seeing the smoke around that. And there was a rumor, it's very unconfirmed. In fact, I would say it has been denied, but you know how it goes, that Valve was potentially slightly reconsidering how heavily they are in the VR market based on the, is going into it. I don't necessarily see that as the kind of thing the Valve would just, up and bail simply because Facebook entered. But I can certainly see where, given a long enough time scale, maybe they focus more on the upcoming Steam Deck, just in terms of resources and effort and whatever. And so, yeah, like their VR efforts remain, but somehow it isn't the driver for the company. I mean, there is precedent for that with, if anybody remembers the Steam machines that run Linux and were going to be the new kind of like universal console form factor, that effort seems to have sort of gone away. Now, definitely that, I think was much earlier in the process than the Vive and the Index and all those other things that they've done, which certainly have, made a big impact on the market and so on. But it is interesting to consider that for a company like Valve, does it make sense for them to push these two hardware projects simultaneously? Maybe they start focusing on one at a time, that is sort of like their marquee product. So I do think both of those things are interesting from that perspective. The Galia presentation from OpenBCI at AWE, I'm still hoping to see that published. There's been some neat, let's see if we can pull up the OpenBCI Twitter. So there's been quite a few photos from, I think, Connor's presentation at AWE. And, there's a slide deck right here. Cool. Let's share the screen. And I'll also share the link. Check it out yourself. Okay, so here we go. Internal states, for those that remember, I'm sorry, it sounds like you're supposed to be watching this intently and taking notes now. But if you were present 6 months ago when we were having a nice conversation, one of the observations was that a lot of BCI and a lot of EEG is really about quantifying some state, finding a state and then being able to identify it. And once you've identified it, either just call it out or do something about it. And so the startup, it's of course I can't remember the name, but the startup distributing crowns for depression in Canada, I'll remember it. Diversity Neuro, was it? Something like that. Divergence Neuro. There we go. So Divergence Neuro is going to be quantifying your depression state, and then as the therapist is sort of doing the various treatments, they can see whether your depression state is increasing or decreasing. I mean, it's that straightforward. So whether it's sleep quality, whether it's whatever, really a lot of BCI can be generalized into state identification. And once you know what it is, then you can decide what you want to do about it. Yeah, combining data from multiple sensors is time-consuming and expensive. And yeah, if you're designing this stuff in-house, yikes. So yeah. There we have the presentation, and here's people getting the big news on this presentation, and I like that the privacy angle is being featured. One of the really cool things about OpenBCI is they are open source. There is no cloud that your stuff is going into, and there's no one that can look at your data, both personal and research data and so on. So yeah, compared to pretty much all the other stuff out there, I just recently got a Quest 2, so I'm giving my data to Facebook. I have a phone, so I'm giving my data to Google and Apple. But yeah, it would be nice if you could collect this data and hang on to it, because it's so rich, it's so, personal. And yeah, so this was a really cool presentation. I don't think we've seen a video upload yet, but definitely I'll make it available once we find it. Yep. And I just thought that was a really neat presentation. So the Galia is moving forward. This was the big announcement. And oh, hey, we're going right into the careers. Wow. All right, so I'll go ahead and stop sharing. But yeah, this is the Galia, not available for pre-order yet. But the emotive bit is, I will continue to say that this thing is super cool, and I will continue to bore you with mine. And if you're wondering why the battery is so huge, well, that's because we're doing some testing on Wi-Fi, and I wanted to have a ridiculous battery life so that we didn't have to worry about it. So yeah, Emotibit, awesome. OpenBCI, awesome. Now I'm going to check to see. All right, we're still. So the OpenBCI presentation was awesome. And AWE is definitely featuring. The HP OmniStep G2 is also doing some strong presentations on their stuff. So I thought that was cool. And again, to reiterate, the HP OmniStep G2 is this new VR device that HP has come out, but it has a heart rate sensor and it has the eye tracking, the pupils. So they can compute cognitive load. They've come up with a metric, they've included it in the SDK, and it's a feature of the product. So I do think that's a very, very fascinating, because here we have OpenBCI announced this collection platform that researchers can use to inform themselves with VR and so on. And I think that is super awesome. And then HP kind of takes this other approach where they're really targeting more the corporate training market. And I think that's also interesting to sort of try to make more of a product out of it. In other words, Valve kind of is the researcher, hacker, quantified self approach, or the OpenBCI, whatever. Just because you have full data, you make your own metrics, you make your own interpretation, that sort of thing. The HP is kind of like an interesting alternate. Here, let's see, HP OmniStep G2. I'm gonna. Okay, that's it in chat. With the HP OmniStep G2, it's really cool to see this first commercial. I've never seen a commercial attempt to take BCI or sensor data before and actually put it as part of the product. But in this, it's part of your training. In other words, you're making people run through this training program. And one of the ways that you can see how well they're doing is their cognitive load dropping over time as their performance increases. So let's see if I can find the video with the screenshot. AWE. And I think we can, this is the VR, Ovation VR. Cool. Okay, turn these down. But here's an example of what a developer could see. Just a moment. Share the screen. So this is the HP OmniStep G2. These are the headphones on the side. And this is what it looks like when you've got the telemetry data within the SDK. So I thought it was kind of neat that the cognitive load, they came up with a metric from 0 to 1. So it's science, because it's Z-scored. And I guess you're supposed to think of it in percentages, 63% cognitive load. That also lets you correlate with heart rate, which is nice because as stress increases, heart rate gets more steady. And as stress decreases, heart rate gets more variable. So when you have the heart rate, you can also compute the variability. And when you compute the variability, now you can look at stress and load, which is kind of an interesting thing to consider. So when someone's doing a new task, maybe they're under stress, maybe they're under high load. And then as they do it 3, 4, 5 times, they get the training, they complete it. Now you can look at the actual like the eye cam's super creepy. And so I think there's other reasons for this as well. But what you'll find with most eye trackers is that they obfuscate the raw eye recording. They just give you either the output or a visualization or whatever, because this is less reaction inducing than when you have the real footage. And I was surprised by it myself. We had a pupil eye tracker that we used for a while, and it's memorable watching an eye squirm around, that's for sure. Okay, so yeah, here the developers of an app or a game would be able to kind of look at the cognitive load on the level, and like right here you say, oh, this part's kind of boring. You know, they're not doing a whole lot, or maybe this is a good break between the action, where you know you have these peaks and troughs, and it ends up being interesting for people. So on the other hand, you've got let's see where folks are. And then on the other hand, you've got the Valve OpenBCI approach where, all right. Yes, and Morgan is on his way back. He's indicating that hopefully Sean and Simon will join. All right, well, apologies for that brief Xfinity-induced delay, but we're back. Okay, so Morgan should be back in a minute. Those are the latest updates for the HP OmniSep. The last thing is we do want to start both a remote and an in-person project that we start doing at these hack nights. I think the current plan for the in-person projects is to start using the Emotibit, because we'd love, you know, the coolest way to do hardware for us anyway is just like once you do the initial experimentation, we always just try to come up with some study, because for some reason when you put an actual goal and do some collection, even if it's totally like informal, you'll sort of run into the same constraints. Anyway, it's good stuff. So we're hoping to do some in-person Emotibit research at Noisebridge once we get that rolling again. And I think it would be super great to do another EEG study the way we did the Spicy Challenge. So I think the two topics that we're looking at right now for sort of like a group collection challenge would be sleep study, which I think would be very, very interesting because, you know, we could do the sleep classification, we could do the sleep quality, sleep staging, and I think there's a lot of personal aspect to sleep, but then at the same time, you know, perhaps sharing the computed results isn't too much of a dicey thing, because really all you're saying is what stage or sleep was at what part of the night. So I think that's kind of like a low privacy invasion, low, you know, whatever type of thing, and it's a cool project. The limitation there is we need several people with Muse S's probably, given that that's sort of the most tolerable EEG device. But I do think that would be cool. The spicy challenge showed that capsaicin generates a strong EEG response in all 3 devices that we tried, which was, I'm sorry, 4. So a Muse 2016, a Muse S, an Open BCI, and a Neurosity Crown all showed really strong responses, and we saw differences in the responses too, but all of them did show a response. So that was cool. In the same sense, you know, I think it would be great to do that sleep study and come up with a set of tools that community members can use that if they do purchase a Muse S, and if they do want to research their sleep, they have a reference that they can look at and say, okay, here's how I do it. Here's how I record my data. Here's how I download this Python sleep classifier, and here's how I install it. The other, I thought there was one more EEG study we were looking at. Yeah, I can't remember what was the other thing that we were considering as a study. But I think, you know, we'd like to get that project rolling again. I'd like to update that GitHub repo one more time, sort of clean everything up before we hop off that project. But these community-driven data collections really seem like a great way to get some more data, get people familiar with the BCI tools that they have, and make it sort of a tangible project. So I thought that was a cool experiment we did. We would like to do it in person, and we would like to do the sleep study remotely. So, and Morgan was suggesting last time, you know, can we share the data and so on? I think that would be a big goal afterwards. If we could make it so that the data we collect is sort of, instead of a one-off, like a launching point, so that if somebody else wants to pick up, add more samples, do their own interpretation, really that's the sort of the open science standpoint. All right, folks, I'm sorry. The guest should be here in a few moments. How about those Warriors? I'm sorry. No, the Golden State Warriors are doing great. That's it. I'm sorry. All right. The other thing that I wanted to mention about VR, and I just thought that this was really cool because this is kind of like another real world application, was the integration of the public speaking software called Ovation with the Omnicept. So I thought this was really cool. Basically, there's software out there called Ovation. And what it will let you do is give a virtual public speech. So this way you can practice and rehearse your performance. But in addition to that, it actually does quite a bit. It will look at your gaze pattern, so where you're looking at the audience. In this case, it's virtual, so they know the location of the audience members. They have the eye tracking built into the HP Omnicept G2. They do actually use the eye tracking. So they know that if you look at this person, all right, you will be at that location, and your eyes will. And so that's going to tell them, hey, you know, this is the audience member. So let's say you're only looking at people on the left for whatever reason, or you know, you're focusing on the center, but you don't glance at the sides and so on. Using the eye tracking, they can basically point out either tendencies that you do too much or things that you do too little. And I think there is something to this in the sense of the self-criticism process with public speaking is kind of rough, because then it's kind of like you're picking your own stuff apart. But I think if you can just have this spit out some suggestions at you, that really does make it a little bit less of a sort of, you know, personal thing. Like, hey, you know, let this software, here's some tips, you know, go ahead and do it this way. So I really think that this is neat. In addition to the corporate training, this is kind of like a real world use that people would actually consider buying, and that would enhance their real world skills using this VR, using the sensors. So there's a microphone, so they can grab your speech pattern as well. And now they have heart rates. They can see like your stress level. And that's really interesting. So yeah, here's like a report, you know, what you're looking at. And speech analysis, are you speaking too quickly or too slowly? And what parts are you speeding up and slowing down? Filler words per minute. Oh, no. And there you go. Look, knows where you're looking and how you're feeling. And this is, I think, the promo for the sensors. So I did think that was really, really cool that that software exists in general, but with the OmniSwept, I think this is kind of like, this is the promise of the tech, if you ask me, which is that you can, the sensors are neat, the whiz-bang reports are neat, but taking folks that are worried about speaking in public, helping them be comfortable with it, helping them be better at it, and finally, here's a tool that improves your ability to do things at work. That's great. But the more of these we can put out there and see out there, I think the better. Pilot training definitely seems to be big on this sort of thing as well. So an exciting time with all the new tools that we'll have available. But this past week was the Augmented World Expo where all of this was really announced. And so while we've been talking about it for the past 2 months or so, this is now in front of the general public. And I do think that's really cool. I do think that this kind of shows that neurotech is sort of going from this very niche thing to mainstream usage, mainstream acceptance, and making a big impact on people's lives. So that is going to be pretty cool. Okay, and the Buzz in Review is coming up in just a few months. We're still nailing down the plans for it, but we do hope to have a big event for that. I think we'll try to coordinate with some of the other clubs, and you know, it's a great event for people to. Not my day today. All right, but good news. Morgan is back in the house. So I think we're mere moments away from upping the quality of this hack night. Thank you all for sitting through my soft shoe. And it's lovely to have you. But to finish up, Buzz in Review, I think, is going to be good this year. And we're hoping to make a big production of it. All right, and again, apologies for the network connection issues. It's definitely something on my end, but it is quite odd. I'm not sure what is going on tonight. It has been an issue any of the other nights. Hopefully it won't be an issue next time either. But I do think it's cool. The student club initiatives, all that other stuff, great to review with the Buzz in Review. And I thought it was really neat last year to see how many startups in the ecosystem participated in that. So you had like everyone that was active in the community, had something to showcase. It really, really turned out. And much livelier than I expected. So if you're on the fence about Buzz in Review, it's actually pretty good. It's a great turnout. It really ends up being kind of like a seeing everybody in the neuroscience community and the NeuroTechX community. So it's great like that. All right. And just sent Morgan the invite. So I think he's joining us in a few moments. Oh, hold on. I have the wrong output device. Yes.
Is that working?
Mm-hmm.
You can hear me. Why can't
Yes.
Give me a second.
Is my microphone working?
And Raphael is in the other room, so we're in the same house, but so that we can have our masks off. Where he's going to be in Ella's room, and let me just check the sound here. Oh, I don't know.
Are you able to hear me, Morgan?
Can we have Simon or somebody check? Simon, can you tell us if you can hear?
Because if not, I think that's going to be a really low quality.
Hello. Okay. I saw my problem with sound. Okay, good. Simon can hear me.
Can you hear me?
Yes, now I can.
All right.
So now let me turn it down. And why am I so bright? Oh, okay, I need to be out here. Anyway, so give me. Now let me message Raphael the Crowdcast. So I don't think he signed up on Meetup.
Okay.
So give me 1 second, and just turn this down a sec. Did you say that Sean is here?
Yes.
Oh, okay. So I don't know if you wanted to maybe add Sean for right now. We could talk a little bit.
Yes.
Just about either California wide or West Coast, including Canada.
Oh yeah, I wasn't sure. Sean, would you be? I'm happy to send you an invite. In fact, I'll do it now, and you just don't have to accept it if you don't want to.
And yeah, no pressure at all.
I was thanking Sean for the awesome NeuroTech LA presentation earlier, and I guess I wasn't sure if he wanted me to invite him up on stage anyway. There we have.
Okay, let me get this to Raphael. All right. Ooh. Okay. So let me just turn on a bit of light that will maybe, hopefully make me a little less glowy. Oh, hey, so perfect. It's great. I think Alfredo is the one who put Raphael onto NeuroTechX.
Oh wow!
So I'm excited. Or tell me if that's true, Alfredo. Okay. Yeah, and yeah. Okay, can't remember. Okay. Well, anyway, it's been great to get to talk with Raphael, who's going to be speaking today about the work he's been doing. And but yeah, if Sean would like to join us first. So I know that Sean needs to duck out at 7:30. So we can give him some time. Lots to talk about today, or lots to talk about from this week. I mean, I could probably spend the entire time just talking about the OpenCV weekly meeting this morning, just because it was super relevant. Somebody from Control Labs was speaking.
Oh,
So,
wow.
Yeah. And they didn't ask any of my questions that I put in the QA, but I was like, "Are you going to talk about neural interfaces at all?" And I think like the people at Open, it had the OpenCV CEO and community manager, plus the guest. And I think they were kind of focused on like, if you want to work at Meta, sorry, it's still hard to say that.
I don't recognize the legitimacy of their name.
If you want to work at Meta, kind of like what are they, what are you looking for in engineers and things like that, like, as opposed to, hey, can you talk about some projects that Facebook Reality Labs discontinued? Maybe wasn't going to be their focus,
Right.
even if I was super interested. But catch, really interesting though. So catch that on YouTube. I think is where they distribute it. In that the speaker, and let me get the speaker's name. Oh, so Sean says I accepted, but it didn't allow me to broadcast.
Oh, that's so. It could be a browser thing.
Okay.
You should be able to maybe reload the page or try a different browser. I've had better luck with.
I'll keep an eye on this, Sean, and we'll figure this out. But let me just remember this guy's name, because this particular okay. So so Dustin Freeman was the speaker today at the OpenCV weekly call, and if for no other reason, catch it for just a really nice history of kind of body tracking. A really nice history of body tracking over the last, kind of 20 years, maybe more like 15. But in addition, some cool UI UX features as well. So I mean, he was definitely doing kind of gestural work before he started at Control Labs, and he talks a bit about being at Control Labs, and I think somebody is like somebody looking for my device. Wait, what's that mean? So somebody, he started at Control Labs, and then like 3 months later, it was acquired by Facebook, right? So he wasn't somebody who was there a long time before, but as you can see as you'll see in the history of that his presentation, like he was doing all sorts of UX stuff that involved the hands. Like he was at Microsoft Research. So, was obviously involved in Connect things and Microsoft Surface device. So definitely interesting. Also interesting in how they talked about the post-acquisition, like what potentially happens with startups, and what's different about what Facebook has said, even though like there's no spoilers in terms of, he really didn't say anything about the what we know, right, is like an EMG device. We've seen what they've made publicly available. The only thing he did say was that like it was nice being told, tell us now what you need to make this device actually happen.
Right.
And that still seems to, that as we know publicly, still seems to be the company goal, right? Whereas, for instance, FNIRS has been discontinued. Right.
Yeah, and their collaboration with UCSF and the Chang Lab and the speech BCI has also been discontinued.
Yeah, I mean, like I don't know if it was ever. Well, certainly it needed more outside kind of things, and was as I understood it, at least the Stanford work that was the first presentation I saw, that was not Facebook Reality Labs funding, right. That was foundational funding. Okay. So I wasn't as clear on what that was going, was it on a product track or, but you're right. I mean, I do remember, or again, I don't know if this was like at, what do they call their developer conference? F8?
Yeah, something like that, like the Facebook.
Yeah, F8
annual,
their annual developer conference, right? There was this we need, why are we working on neural detection? To get what we want is words per minute,
right?
Like that would be a actionable, like a metric we would care about that would translate into, obviously we can now do text to, thought to text, right?
Right.
And let me so Raphael, are you on?
I see someone in the.
Okay. I'm new to this interface.
It's so you see where it says people down below. If you
yeah. Sorry, he's there. Okay.
And then I can invite him.
So let's can we
sorry,
not fix Sean? So
I can try. All right, let's try this. I'll remove Sean's invite, and then I'll send a new one.
Okay.
And
I'll.
Sorry, Raphael. False alarm. I'll invite you in a moment.
Yeah, because I want to just be cognizant. Or can we have them all? How many can we have? 4?
Yeah. We could have both.
Why don't we?
All right. We'll do the Hollywood squares.
Yeah.
Raphael.
Plus, I just think it's funny that he's actually in the same house with me.
we try to be as ridiculous as possible here on NeuroTechSF.
Yeah. Canada, yeah. Okay, it does look like I'm glowing, doesn't it? Okay. I can turn. Let me turn the. Is this why I'm glowing? All right. Is that better?
I think your inner luminescence just comes through on these hack nights.
Say the nicest things.
All
right. Well, I mean, I can. Let me see if he's. Well, let me just flesh that out, or let me just think about anything more from the OpenCV call. Well, and then in talking about the kind of goals that we have at NeuroTechX, I'd love to see, and I know I've got the OpenCV. I mean, it's one of the reasons that I was interested in the call. This is a weekly developer focused call, or online meetup. But as you might know, they had a recent Kickstarter to basically get a hardware device out there to the world. And so they've got a couple different devices. but the one that I think we should care about is the one that could become a simple eye tracker, or certainly we should be able to do. I mean, he says he hasn't got a new invite yet.
This seems like a little bit of a glitchy interface. Let's see.
Well, let's see if Raphael.
Are we talking about Sean or?
Yeah, Sean's.
Don't get.
He says I also can't type in chat.
Oh no.
What? So let me see which browser he's using. I don't know. Well, we can
remember it being this tricky. Sorry for the challenges tonight.
Okay. Well, so Raphael's got a problem too. So he says he's Try Chrome. No worries, Sean. No worries. Yeah. I mean, I'm using I'm Chrome on Fedora. Yeah. I can. I mean, the good thing is that I can actually ask him to come over.
Right. And you could, I guess, improvise, use your phone. Worst case.
I could switch to a different laptop and let him use this setup.
Okay, so I removed the invites just in case that clears up whatever. So if you get back from the browser, I'm happy. I have no idea why this isn't working, and I'm so sorry about it. That's all I'm really trying to say.
No problem. I mean, hey, we've had problems with Jitsi before, so sure. Try what you can, Sean, and nobody worry about technical problems. We'll try and get them sorted. OpenCV is making hardware that. So it's interesting that. The community manager for OpenCV is a former Occipital engineer. So Occipital is the company that makes the stereo camera that attaches to an iPad, and as people might remember, we've talked about this before. The Donders group. So in particular, I mean, the field trip developers put out a manual for how to use an iPad to get electrode positions from the head. So, with a stereo camera attached, so it's like a mini Kinect attached to an iPad. You can then take the iPad and, just move it around the subject. You build up the 3D head model of that subject with the electrodes, co-registered. Right. And this is, for those who are coming from, Cognero research doing this, typically you would use a kind of magnetic receiver device like a Polhemus that is, like 6,000. Oh, okay. He thinks he's in. Or like, let's see. So it's working to some degree.
I think he should pop up in a minute if it all
Hopefully
goes
pop up in a second. Nope, just got an error message. Yes, thank you, Alfredo. So this occipital says OT timeout.
All right, let me just check. Crowdcast, OT timeout.
All right, he's working on it. Let me. Well, if somebody wants to Google this while I'm checking the occipital EEG lab, I think they also make a manual, or you can check field trip occipital, and you should find the instructions for, collecting that data and then converting it into a MATLAB data structure that either EEG Lab or Field Trip can use. And obviously, our goal would be to make that a non-MATLAB data structure. as well. So one, like the Electrode position kind of replacement, again, like a Paul Hemus device is maybe $5,000. Although honestly, these days you can get these old Paul Hemuses from eBay for 500 or less. There are some the problem with Paul Hemus. Smith Kettlewell Eye Research Institute uses Paul Hemus and has a wooden chair in the middle of a really big room because any metal that you had. Okay, so if you could invite Raphael again.
Yes.
Okay. This is one of the problems with Paul Hemus is that like if there's any metal in the room, and you haven't recalibrated it for the metal that's been brought in, then you can end up with really distorted electrode positions. And you get this pen, and then like collecting the head shape data with the pen is kind of silly. It's like definitely not meant to be rubbed against you. So people put all sorts of things on the tip of it, and anyway, it even trying to get a hack. It's okay. It says invite is expired. Maybe that's
we just sent one. Okay,
maybe,
hold on a minute.
Okay.
Invite on screen. Yes, I think I just clicked. Oh man, this is awful. It's all going poorly. Hold on, I think there's a way to. Oh, sorry. Go ahead.
Well, I can switch him over, but then the only thing is that I want him to have his presentation.
Oh, hold on. We've got signs of life.
Hey, that's Sean. Yeah.
What a massive disappointment everybody on this call must have felt right now.
No, not at all. Very good, because I know you're going to need to go in maybe half an hour. Yeah, I know.
This is the awful
here. This is the awful
Looks
thing.
good.
Disaster. Everyone deserves better than this.
Hey, you've got hair. I don't.
Yeah, look.
This is what happens when crowd
better. Yeah, we can work with that.
We would love to have bedhead.
I wish it was bedhead.
Yeah. Anyway, it's great. It was great talking this week, and yeah. So let's fill me in. I'm the one who's been gone. Fill me in on what the LA chapter's done this year, in terms of events and what you're interested in doing.
Yeah. So obviously at the top of our list is talking about a partnership with San Francisco. We also have two groups here. The UCLA group is really kind of interesting. It was before. And the USC group, a little bit smaller, and I think they got busy and sort of put it down. We also think there's a huge opportunity in Orange County and San Diego because UCI, University of California, Irvine is huge, and UCSD is obviously a research powerhouse. So our goal is to be able to put on LA-centric events that are unique and interesting to LA, but maybe not interesting to other groups, while having these shared groups that are interesting to everybody. And the hackathons are particularly interesting. We tried one of those. San Francisco has way better engineers, so ours didn't go as well as yours go.
I mean, like I said when we talked yesterday, we had remember our last in-person meetup, Alex?
Yes.
It's like we had a number of devices for people to hook in with, but installation problems were installation and connectivity issues were like barely solved by the time we were done, and I don't want to say it pushed everybody away, but I mean I think it pushed away, like we never saw this one particular obviously very experienced Python developer
Oh no, yeah, we had such a good turnout, and it went so badly, and oh, can
Honestly,
we
I
not
don't
blame it on
know.
the pandemic? It was like 2 weeks before the pandemic. I mean,
It was.
we can
It was.
we can
It was
we can
like,
just say it was that. No, actually, I completely agree, and in a funny way, that's what's was one of the impetus for this hack project that we did with the capsaicin or the sleep study or whatever. If you actually get people to collect some data, then when they come in person, you know what to expect, and you have at least a few people that are working that can show others the ropes or whatever. Because yeah, that experience of having nobody working was tough. It really feels like, oh my goodness, here's 10 people and like, Merry
Yeah,
Christmas.
so our solution to that, we don't have one, but our hypothesized solution to that is one, go cheap with the hardware. So we have a few muses, but obviously muses are hard to distribute, especially in COVID. And I'm like a freak about safety, so I won't go within 10,000 feet of another human, even though I live in LA.
I'm going to talk to
And
Josh.
then there's
We're
the
going to talk
idea
about.
of having virtual machines that people can tap into, maybe via their browser or something like that has everything loaded for them, and we
Right.
can distribute everything and it's ready to go. So that was one. But also, like you talked earlier about the emotive bit. I mean, I think that's huge. I believe it's relatively cheap, and that's
Yeah.
something that could be easy to distribute.
200.
Andrew, who's my co-admin in LA, he has a project. I think it's on hackaday.io, and that is about hacking some EEG device. He's going to be mad if I don't remember, but I think it was an emotive, or maybe it was the Muse that he hacked it in some way. And so, basically, I love the idea of creating new forms. And actually, so this segues unnaturally. Sorry, I tell Irish stories even though I'm only half Irish. This sort of segues nicely into sort of some of the stuff we did earlier this year, which was we brought in a guy named Professor Joe Froelich, who is focused on a lot of consciousness research and does a lot of EEG work in the Monty lab that's at UCLA. I'm working with with another grad student from that lab, and that lab does a huge amount of work on consciousness, neurocorrelative consciousness, and that's like a really interesting lab. I've tried to get the guy, Professor Monty, to speak, but I've been told that he's like whatever you think busy is, he's like beyond it. So he's like hard to get. We also had Professor Brad Wojtek at UCSD speak. He was
That was
awesome.
amazing. That was amazing.
I know you know him, Morgan, and we've had another. We're trying to get Judy Pa, who's like at USC.
Okay. I can. Oh, okay. Sorry, Raphael's just sending me a message. So I know Bradley from the same lab that I know Judy.
Okay.
So we were all in the same desk area.
That's awesome. Judy, I think she wanted to speak, or maybe she was kind of lukewarm on it when I reached out to her. But she sort of said, "I'm too busy now. I'll push you back." But I think she'd be awesome to talk to.
So like I told you, next week we're gonna have Jody Mishra, and back in Adam Ghazali's lab, Jody was just in the desk area to the other side, and so I let me, would you mind if I get in touch with Judy and see, and basically, like we were talking about, we can co-host, you put out the same announcement that we're putting out, and we're just centralizing this. We've talked for a long time about renaming this particular weekly meeting. One, we don't feel like we're doing a lot of hacking.
No, we have.
It's a historical legacy from before COVID, right? And to a time when we kind of used the co-lead's garage as our meeting space, and like because it was in person, and we had full control over the space as long as the car was pulled out, and and there was hardware devices that were lying around. I had an old EGI 128 system that was sitting in the corner. for people to work on. And like that was how Hack Night started, or that was why it was called that, right? What we're definitely trying to do is and one of the reasons that we're on from 6 to 9 is not that we're trying to do a 3-hour podcast, but really just be available in the same way that the garage was, in sense of like come from 6 to 9. But the kind of events and having speakers like Raphael and things, is a great way to actually do outreach, right? And so it's like we should be sending this out to everybody in our time zone at least, and if not, I know we sometimes well, Manuel's I think he's 3 hours ahead, right? Olivia's 3 hours, yeah. Yeah, we should do more hacking. I mean, like, well,
so I would agree with that, and I'd say like I think we reposted some of your. I mean, probably have not done it well recently, but we definitely want to do that and share that. I think, I think it's important to have the professors talk, because that's just interesting. Like you were talking earlier about sleep research, and I think that's really interesting. One of the things I wanted to add, but couldn't until I used the app, the chat function, was we had this guy who's now been eaten by Facebook, specifically Oculus or Meta or whatever they call themselves. But he did research at a lab at UCI where they actually sent a tone while they were sleeping, and that aided in memory as people went through a virtual maze. And I was like, why is everyone not learning this way? Like, why is there not like? And I mean, I think it's interesting because all you had to do was listen for sleep spindles. Anyway, so I think there's a lot of opportunity for that. But I don't think that I don't think hacking is great for everybody. But one of the things that we are that we wanted to be focused on, at least we wanted to be focused on this year, but we weren't very good at it. Next year, hopefully, is just learning what our community wants and giving it to them. And we know that it's segmented. And I'm passionate about helping researchers accelerate science and accelerate their research. So that for me is data science, AI, robotics. That stuff's interesting to me. But the Emotivate stuff that you're talking about was interesting because the guy that we got to speak first, Joel Froelich, he wanted to do a whole bunch of studies in float labs. So basically sensory deprivation labs. But the test for that for EEGs is not that good because if you think about the challenge, it's isolated from the environment. It's in saline, you're floating in saline water. So our idea was, why don't we try to hack together like new types of EEGs? So that was something that we thought about, and I think would be really cool to get a group together that just does that, or it's like a committee maybe. I think when we're hacking, even if we're doing it virtually, it'd be cool to do pair programming or pair data analysis virtually. I think that's pretty cool. Like maybe someone's not super savvy with Python, they want to learn Python, so they do pair programming stuff, pair development stuff. Someone's got a maker lab. I mean, just there's so much opportunity for creativity that, and California should. I mean, I'm biased because I'm from Chicago and then I idealize California, moved here, but like California should be like leading the charge in terms of innovation. It should be no other place in the world. We should be doing the most cutting edge shit in the world. So,
and so I want to give, So I'm gonna actually switch over to let Raphael use this computer. Okay.
Yeah. Delete me out.
No. It's not.
That's not to. But I do want to also say, try and add Josh, because Josh will I'd like to make sure that he's not going to have any problems joining. So Josh will be able to speak about hardware that will hopefully be even lower cost, as well as like when we have more control over the hardware. I mean, one of the problems that we have with the Muses was really it wasn't so reliable. I mean,
No.
maybe part of it was that we were trying to access the device directly. We were bypassing their software. There was issues about like, well, are you using this particular dongle, and things like that, right? If the better we can control the hardware, then a lot of things can be easier. And so anyway,
I just want to agree real quick.
Go ahead.
Sean, sorry. I totally agree. I wanted to try to put together like a straight up Hack Night series, but we just didn't have any interest. Like I couldn't, no matter how much I advertised on Slack or whatever, I was like, if you want to share your project or have other people look at your Python code or help you with just building your environment or getting the data, please join us. Nothing. So
I would say, if I would add to that, I would love to be a part of that.
Okay.
I don't feel like so my Python is blah, but like I feel like I would really benefit from having like a project to join and to help with.
Right.
So maybe that was the issue, is that people are not at the right level or whatever. But
okay, cool.
I'm in anytime you want.
That's awesome. I'm super excited. Okay, so we'll coordinate that, Morgan. Sorry to interrupt. And Josh, welcome to the stage. We can't hear you, sir.
Hey guys, you can't hear me.
I can hear him.
We can.
You can? Okay.
Yes,
okay.
Works good.
Delete me before Josh gets rolling. Sorry, Josh. Delete me out so that because I have to leave in like.
Okay, sure. We'll close your window. And thanks so much for joining us, Sean. And thank you so much for that Dr. Wojtek thing. That was awesome. Thank you. Yeah. All right. Okay. All right. Josh.
Hey.
Tell us about the low-cost emotion hardware.
Emotion hardware.
Oh, I'm sorry, EEG hardware. EEG hardware.
Yeah, we'll talk about algorithms later, but we're making progress. So I've since redesigned this, and I'm waiting for a new version of this. But so this is a Bluetooth 5 plus 8-channel EEG, ADC on it. So I can use this for EEG. Mm-hmm. I've successfully streamed Bluetooth 5 off of that now at 500 samples per second off 8 channels. The noise is it's just amazing. So now we have to do some actual data testing. I just have this hooked up to Bernard's headset, so this isn't like a real setup yet, but I'm gonna get that going, so then we can actually validate the signal quality. But it's like 300 nanovolts of noise, and that's a $4 chip, so that's kind of amazing. So then I'm reworking that. We've got we're using Zephyr, if you've never heard of that. So it's like I was using Arduino because I didn't know what the hell I was doing. And now I'm using Zephyr, which is, I still don't know what I'm doing, but it's the next level up to professional microcontroller software. It's really cool. It's built on Linux, so we can build these, I could build a Bluetooth, so with the Bluetooth 5 and the ADC, it was like a 24 kilobyte program. Mm-hmm. It's pretty remarkable, and then it's super low power. So far it's using 10 milliamps of power, and then on a little 300 milliamp battery, right? We could run that for a day and a half. And then I don't know. There's all kinds of stuff happening with that. We're working with the rehab center as well. So we're making. I'm building a headset out of this. I'm going to mix FNIRS and EEG, and then we're also making a wrist wearable, kind of like the Emota, right, where it's got a bunch of different sensors in it. So it's the same idea. And then we're playing with some software to interact with clients potentially who are in rehab. Sorry, that was a big ramble.
That's super awesome. I've always wanted to ask about this one particular device, and the compute stick. I mean, obviously it's expensive, but is that quad core Atom any good in your opinion for that kind of stuff, or do you think it's just overkill for the price point?
Compute stick. I'm gonna have to.
Compute stick. It's an older piece of hardware. Intel hasn't really. But what I thought was wacky about it is you get a quad core into Atom. You get 2 gigs of RAM. They have like an integrated thing, but it's got Wi-Fi, 802.11 AC and Bluetooth, and it's even got an HDMI out, so you can kind of like plug it in to stuff. Yeah, for like anyway. We messed around with that a few years ago, but I was just curious. Like, yeah, sorry.
Right. Yeah, I don't know. I mean, what would you want to use it for?
Like an Arduino type of thing? I don't know. Just a remote Linux.
I don't know.
Okay, fair enough.
If it supports it, then yeah, why not, right? We're going for the bare minimum. So I've got like it's like a $7 microcontroller. It's got like a megabyte of RAM and 256 kilobytes of RAM, megabyte of flash. And we're trying to go for the absolute most cost effective. And then the design we've done, I think I can show my screen here.
Yeah, you should be able to share for a minute.
Just bring up a screenshot real quick. So it's designed kind of like an Arduino breakout board or something. And then, so it's got a bunch of GPIO on it, plus it has the 8 channels. And then I'm going to be able to daisy chain more of the ADCs onto it. So I can make 16 or we're going to try 32 channels as well. I mean, this is really pushing the Bluetooth.
Right.
We have to try it. Because then this board by itself, it's like $25 worth of parts, plus like with assembly, that's building like 100 of them. And then, it's like another $10 per 8 channels that we want to add. So if this all works out, we're going to have, the cheapest EEG on the market, right? We're hoping, this is all open source, right? We licensed it AGPL, so it's the most aggressively open source. So the idea there is to try to make that viral, right? And then that's dovetailing with a bunch of software projects as well. So we've got a whole web-based biosensing framework, and then we could do real-time signal analysis. I'm writing like GPU not compute yet, but it's GPU kernels. And then when WebGPU comes out, I'm going to learn compute shaders. I think I turned this off. Share screen. That's the button I wanted. So here we go. Did this pop up? Can you see?
Yes.
Oh, here we go.
Yes, right here. Yep.
Cool. Yeah. So the board I showed you here. Let's break this up again. Such a massive wires, but so this is draft 1. This is draft 2. So it's a bit smaller. It's like an inch by an inch and a half in size, and then it's got this super tiny little microcontroller on it. It's an ARM Cortex M4 plus an NRF Bluetooth stream. Backside it has the let's see if I can. Here we go. Yeah, backside it has the ADC. So you'll have GPIO, do whatever you want with it, plus a really high-powered 8-channel ADC. It's a Sigma Delta, simultaneous sampling, blah blah blah. It's what you want. The only problem with that is that the input impedance is only 1 mega ohm, and then I've added 1 mega ohm analog filters to it. So we know we can get good data off of it. Plus it has some analog low pass filters on the chip itself that seem to get rid of like environmental saturation. We'll get these DC signals where we've got the gain at 32x. So if there's too much DC, then that saturates, right? Mm-hmm. And then what happens is if you have enough input impedance, that helps just get rid of that off the like from the get-go. And we were having issues with that, but this chip has its own just solution for it on board. So far so good. I'm not going to say it's the best ever yet, but once I know for sure, I'm going to say it's the best thing ever because we can put these out for less than $50 a pop, no problem. Wow. The idea is to try to scale this, right, and make this viable. Like as a business, really, but I've thought more and more about, what I care about here is trying to make mental health tools, and I care about the idea that, this is going to contribute to what we understand about the brain, which is then going to contribute to, actually helping people heal from all kinds of nightmarish, mental disorders, or the substance abuse epidemic going on right now. I mean, it's all the same thing right now,
Right.
at least in terms of how it's all people's brains dysfunctioning, and we're not really finding it like good answers as a society. And we live in this privatized medical system. Everything's you're going to go bankrupt if you don't have insurance and you try to go into care. There's all these things where I guess I believe that if I could come up with a open source, really low cost solution that can start to get into this space, right, then I can sort of have an impact on just the whole healthcare market. You're trying to get us away from like all this for-profit crap and into like let's make this actually socially oriented. Let's support people's healing, and let's support science. And I mean, most of us work out of pocket anyway. Right. I mean, it's the scientists too that struggle with this. So I don't know. There's a lot really that I hope to have some impact on in my lifetime. I've seen a lot of my friends deal with really serious issues, and there was never really good answers for them. Rarely good support for them in the community. So it's like, we got to figure something out, and that's what I want to contribute to.
Well, I think you are onto something very promising. The NeuroSky. If you remember that thing from a few years ago, that was like a 1-channel electrode thing that would go right in the middle of your forehead. You would do the ear clip, and it was $100, but it was super easy to use. People used to use that thing all the time. Like,
I still do.
No matter what hack night I went to or whatever, like you would see the NeuroSky. And I think the fact that the Muse is $200 to $250, I think the fact that they don't officially support this stuff, so you have to go into the weeds and get the software. I mean, these are all real barriers. But yeah, there's
a lot of business barriers with their licensing, getting access to their sources.
Absolutely, and they've been very.
I mean, this is all going to be just out there, so you can do whatever you want with it.
So I think that would be a really cool thing. I would love to see the spirit of the NeuroSky come back, and see a device out there that is like the entry-level choice. Not that I'm implying that it needs to be entry-level, but like from a price point perspective, so that you can really start on these projects. Yeah, and learn it.
I mean, we're going for some entry level just because that's widely appealing, but it's a design it scales to as many channels as we want hypothetically, and we can hopefully then just have one piece of hardware that we have to worry about, and we know it's already the best and the lowest cost on the market. Right. I don't know. It's interesting. I'm also working with other people. I mean, I've been working with the Free EG32 project, trying to harangue all the issues with supply, and I mean, we've sorted out a lot at this point, but it's just like, but anyway, so there's Dmitry. He's in Russia. So he's a Russian developer working on hardware. He has a terrible time accessing this stuff.
Just so you know, Dimitri's actually here with us right now.
Yeah, Dmitry.
Yeah. Anyway, just saying hello, and if you'd like to come up on the stage, we can invite you. Hi, Morgan. We're just wrapping up with Josh, and then I was going to switch to Raphael, if that sounds good. Yeah? All right, cool. So, yes, Dmitry is in the audience. All right, please go ahead, sir.
I'll wrap up. Well, so, like, Dmitry, it's hard for him to organize, like, creating a business around this stuff in Russia. So, like, one thing I'm doing is I'm just helping him organize it. So I can help, arrange shipping, manufacturing. I can help him, get supply into like a warehouse at Mauser or something. I'm now working with another guy, Mohat. You might know Mohat Patil. He's got like an HRV design he's coming out with. So I mean, but he's running into the same issue where he's in India. There's all kinds of supply issues and cost issues. Like there's inflation and stuff that they have to deal with just from things going overseas back and forth. And then they have, I guess he was telling me they have like potentially less access to like AliExpress. I mean, a lot of things I just rely on. So it's like another situation where I'm able to help him potentially. We're working through it, but this is all just like as friends. And what I want to do is try to build an ecosystem of open hardware and just really bright minds like these people. And this will be my contribution, but then hopefully we can have a whole network of this. The software resources we're coming up with Brains at Play. It's the same idea. It's a bunch of libraries we're turning a corner now with all the tech that we've thrown into it. So now we're working on actually like making it usable for other people. But it's the same idea where it's a bunch of libraries for building high performance web applications. It lets you just stream data right into the browser. We can do GPU. Now I've built a whole multi-threading library, so you can build a whole multi-threaded pipeline just in like a few hundred lines of JavaScript in a single page. So there's all this stuff where now we can build also really high quality, high performance applications to go with this hardware that's high demanding data streams, potentially all this crazy analysis we can do, and then we're just making that available. Anybody will be able to do whatever with it, and the idea is open source. Hopefully we can all start to work on the same ecosystem and not necessarily feel the trappings of money, corporate, all this other stuff. It's the open web and IoT. That's kind of the spirit of it. That's all I got.
Josh, it's great to see the effort on this. I've been excited about your project the whole time. I still think it's super cool. Awesome. And so, yeah, I'm very excited about Brains of Play as well. I mean, this is just great. So thank you so much for showcasing the update, and I hope we get another one soon.
Awesome. Yeah, always moving forward.
Cool. Thanks, Josh.
Thanks for having me.
Yeah. All right, here, I'll if you want back on the stage, please let me know if there's anything else you would like to add. Same offer. If anybody wants to comment, just let us know. Raphael, I will unmute you if that's okay, but if you would prefer.
Yeah, that's completely fine. Thank you for hosting me here. Bergen, no, he's not here yet.
Yes.
He's joining from the other room.
I'm rapidly charging a laptop. But,
okay, you can also use an iPhone or an iPad, just to let you know as well. You can use an iPhone or an iPad as a backup. There you go. There you go. Oh, right, and this is Dimitri's the NeuroIDSS project. Thank you very much for providing that free EEG, stackable high performance. EG, that is super cool. Raphael, I'm super excited.
You go ahead.
I'm super excited to have you with us. Now, I have to say that I'm not as familiar with your work as Morgan is, and I'm very sorry about that. But I'm super interested in affect classification, emotion classification, and everything to do around it. My personal exposure has been the Affectiva product and solution suite. We've done demos with it, we've shown it to people, and so on. And I remember when it was integrated into the iMotion software. So that was sort of like, they used to do demos like I saw them at X Tech 2017 or something like that. There was a thing where, you would walk by and there was a webcam pointed at the audience, and then you would actually see your data as you walk by, and it would rate your emotion. So like if you were smiling, it would talk about, you're smiling now, or if you're frowning or something like that. And I thought it was kind of trippy in the sense of, it caught my eye at the conference. Like, wow, look at that! I'm being classified without knowing it. But it was a cool demo. It was very compelling. So those were my two exposures to the emotion classification. I did have some questions around the categories that they were matching and how strongly they asserted them. Because like with the Affectiva, they're kind of giving you like 16 different things, and each one is rated 0 to 1 concurrently. But I was having a hard time sort of understanding the full workflow, right? I mean, if you're targeting one emotion, great. But if you're trying to disambiguate the overall state, that seemed like a lot to sift through. So I thought it was super neat when Morgan announced that that you would be joining us tonight. And I apologize for such a poor introduction, because this was largely about my experiences with affect detection. But if you would be so kind to tell us about yourself and your startup. And again, if Morgan was here, this would be going a lot better. And I'm so sorry, but please go ahead.
Yeah, no worries. I mean, I just had like a quick note, just like when I wanted to interrupt you before, specifically what Josh I was talking about. So I'm coming like from Europe. I mean, I'm originally from Israel, and I'm based in Germany for the past few years now. So I have good contacts with like the Fraunhofer IZM. So the Fraunhofer network is like a research institute that can take like research work from universities to introduce that into the industry part. And specifically the IZM, that's the Institute for Microelectronics and Integration. And these guys are doing a lot of stuff that can, if you're interested in that, you can look that up. I have good contacts with them. So just like for you guys for the network here, if this is relevant.
Okay, that would be really interesting. So this is, I think for both Josh and Dimitri, that would probably be relatively interesting as things to follow up on. Maybe we can try to facilitate afterwards, like exchanging contact info, just so you can follow up on the conversation with each other. But I have a feeling both of them would greatly appreciate just at least checking with you. I mean, maybe there is or isn't.
Yeah, I mean, they're based in Berlin, and it's really impressive with what they have there like on site. So with that, like a bit of like a side note, let me just like go ahead and share the screen.
Okay, so let me make a quick note. So we're going to do email thread for Morgan, Raphael, Dimitri, and let's start with that, and then and see. But that's super awesome, and I can't thank you enough for mentioning it. Just like Josh was saying, this is a small community, and it's amazing what happens when we just connect the right people. So it's wonderful that you pointed that out, because anything like that where we can help facilitate, hardware projects, access to software, resources, and so on is really, really great. Thank you so much for that offer.
Yeah, sure, no worries. So even though you don't have like the basis like for like effect classification or like computation there, so this talk was originally designed to go like from really like to try to bring this from scratch into a level where you can to have like educated discussions with people about this topic. So this was like the original idea like behind this like topic here. So I said that I've updated the logo here, and I forgot to update the date here so you can see the date like I last gave this talk. So again, so thank you for the kind introduction again for Morgan here for like inviting me here, like really beautiful like to have this kind of like experience here. My name is Raphael. I founded Letos as an initial project, and then as a startup, and then as a startup company around 5 years ago. This idea stemmed from my work in medical devices field, where you can see a lot of those kind of like engineering developments that are going into like remote healthcare services, and like more recently with those kind of like consumer electronic devices that can monitor like our physical health. And this is where I can say, is there a path where we can cross different domains together? And if you go now to a psychological, like a psych physio lab that are actually evaluating those kind of like experiences, specifically like a case in point, iMotions. I believe they are a Spanish company. And then to have those kind of transitioning from like the lab environment where we have a lot of those kind of like wearable solutions, like the head cap, the special glasses, and all of those like electrodes goes over your chest, your wrists, like for everything to have there. And to see if we can actually introduce that to consumers at the same level we introduce this to consumers for monitoring like health aspects. So this is what we're looking to see here, to see how this eventually like will evolve here. So just to go a little bit on the background and to see where this exactly falls in. So when we have any kind of like interaction with a person, then first of all we employ trust to see if we can trust the interaction initially. So this goes with human-to-human interaction, human-to-machine. A very good example for that is the recent Tesla cars, or the test of like autonomous vehicles. I know that a few years ago, a colleague of mine in Boston told me that they were looking to start experimentation there, like for like autonomous cars, and people there, their local residents, showed like really high level of distrust, or like if this technology will eventually kill someone or a pedestrian like on the street.
Right.
Because of those kind of like hype from the media, like regarding to that.
Mm-hmm.
And then once we have this initial establishment of trust, and then we go into a stage like we see here, like in the middle, in between. So this is like the motivation part. And then during this kind of like motivation part, this is like the core part of our interaction. So we use, let's say we use, so I'm here right now in San Francisco, let's say I use the Clipper system for the first time. The card we use like to travel here, like on the trains. And how I like experienced that for the first time initially, and if I will continue to use that versus like if I will decide, okay, like I don't care about like dealing with. So for example, today I like tried to load the card with my credit card, and the machine didn't accept that. And then the question here comes like, if this is kind of like those kind of like demotivations that will eventually say I will not trust the system or the whole service in total, and I will use like a different solution, let's say Uber or some other transportation to take me around the city. Now like should I go like here into attachment, but this is kind of like to dive deep here like into this part here. So specifically for this kind of like trust, like for the yes/no situation. So this is let's say we've established part, this part. And then like for the motivation part, this is like divided into like two parts. So what's kind of like activities like motivate me as an individual, and this is mostly like pleasant or like positive experiences that I'm having. And then this goes like to be engraved in my memory. And I have this like kind of like a reorganization in the head, like in this time, or the negative experiences like I had, as I mentioned earlier today. And to go ahead and like and do these kind of like activities there.
Hi, Raphael. I think for some reason maybe when Morgan switched devices, but it seems to have frozen, which is terrible because of course you're presenting the material. So I think we just got to the prototype evolutionary model slide, the base reaction survival instinct. And I have to say this is very interesting. So let's see if we can just double check. No, actually, you're fine. Never mind.
Am I? Can you hear me in real time? Okay, and I lost the video feed.
Hey, I'm back. Sorry,
Can you hear-
Raphael. Yes.
Oh, I mean, so like it says, like, people here say like they can hear me fine. So I don't know like what point exactly you lost. You guys like
Just
lost
when you started this slide, if you can just redo this one again for my benefit. Very sorry. So I saw the previous one just after you flipped on this one.
Yeah, sure, no worries. So I'm just like go back to this slide. So we only have like kind of like those kind of like establishment of like trust, and I say here like listed here like activities like when we apply like touch, look, smell. So this goes like with texture. If it's, for example, let's say a new car, then maybe the smell of it will like make you like a bit different reaction to it. Maybe the texture of like the interior of the car will like make you different. There are like a lot of people like that are going into like interior design and to see how this will be like trustworthy to the individual to trust the system and to use it on a daily basis. And then once you're looking to become like a continuous user, like a continuous consumer or a customer or a recurring user, and then like for example, if you're using like Uber for the first time, then probably your motivation to continue to use Uber versus like to switch to some competitor, let's say Lyft, or when we will have eventually those kind of like autonomous vehicles, like to switch to that kind of like mass transportation models.
Right.
Then this is where you have like those stuff like pleasant experiences. If the service is like flawless in this sense, if the user experience is nice, whatever you have as different like factors there that will improve you, like to take you this. If I will go back like to one slide here, to take you here, like and then eventually to move on to where we have like this kind of like attachment.
Sorry for such like a real world example, but like if one goes to a restaurant regularly, and if you have sort of a similar dish or you're just familiar with the menu, from time to time, you're going to have a bad experience. like the food won't be prepared right, or there'll be an off night or something like that.
Yes.
But it is interesting that it kind of changes it, right? As long as you're having a pleasant experience, it's a big part of your routine, you look forward to it. But once you have one or two really bad experiences, it certainly changes one's, motivation to go back there, so on. So I just find that a fascinating real world example of what you're describing.
I mean, so like to follow that example, so you can definitely move on to fall back from being motivated to go back to the trust. If I trust this, like altogether, I can give like even another example. I read a post on Facebook from a human resources recruiter there saying, use this list of 20 questions that can predict the future if the candidate will be good as a good fit for the company and the culture, like whatever.
Yes.
And what you establish with those kind of like questions is not the prediction of the future, which no one can do. What you evaluate with those questions is you can evaluate trust. Can I trust this person or individual to actually go ahead and pursue this position? And so I don't know if this is something that, because usually human resources people are coming from the psychology field. So maybe this is something that like lack of understanding of the field, but this is what we're looking to have. This is the most primitive thing that we're applying. And this goes like when we're, let's say how you can learn like some certain animals like fear from like different colors in the wild. So you have those stuff like that they're like fear from that. So you have like an initial fear that will prevent you like from even interacting with that like to begin with. So just like to wrap up about this part. So this is for like for the motivation. So as I mentioned, so this can go either increasingly being motivated to continue the activities, or to decrease time after time until eventually we distrust the system altogether. And what we use here actually is we use our ability to sort those kind of like events into positive and negative. This is how our brain organizes those kind of like activities. When we have like those kind of like positive events that will continue like being engraved into our memories, and like also like the negative part. So this is like also being engraved as a again, like I said, a bit of like a primitive like prehistoric parts to go ahead like engrave like negative memories, like in this case. So just like to go with the basics. So emotions, feelings, and moods. Emotion is a very short-lived event. Can go from half a second to a few seconds. This is, for example, when I'm telling a funny joke, and you have the initial chuckle and the smile that goes on your face.
Sorry.
What happens is after a few seconds after you have that,
oh no, yeah.
I mean, you don't immediately revert back to sorrow or like negativeness. You have this kind of like a feeling that can last, let's say, for a few minutes after you had this. So you don't present the level of the smile on your face, but your inner feeling is more positive than it's negative.
Right.
And then you have the mood. So the mood is something that is kind of like a baseline. So let's say we wake up with in a bad day, and even though we will hear a joke and we'll maybe laugh because of that, but because of our initial state that is let's say a more negative mood, then we will revert back quite quickly to a more negative state. And this is something that people sometimes forget, that we need to have this kind of like mood activity is happening regardless of like what we have when we wake up. I mean, we don't wake up as like non-robots. We have some either some bad event, but like bad dinner I had yesterday, or a very good date I had like last week, and that put me in a very good mood. Let's say I'm like going to the gym every day, and like I'm training, and you release endorphins, and this contributes to your really good mood. So this is like kind of like a baseline that we have there that goes that can last like for a few days. So this is like for just to place that on the timeline. So this is to put like everyone in the same group. And then this is the model. So the model is something I derived for a shortened version of this presentation 3 years ago when I was speaking at the NVIDIA GTC event. So this is where we can see here from the left side all the way to the right. So the left side is where we can see the kind of like the stimuli that we process that will actually result in the end events. So what companies right now are looking to have, so this is where you can see the solutions here. So when you mentioned affectiva, so this is like for the facial expressions or like the evaluation of the different facial muscle movements. And other companies that use like voice intonations, eye movement, like skin temperature, like skin moisture, all of those kind of activities, I like to call them like the byproduct of what we experience. But what we can say, we can have like a step back. So this is, for example, where eye motions lives at. They live here, where they say, I'm looking to evaluate the outmost immediate experience once we process the activity, let's say in our brain, and then it's being immediately being information is being delivered automatically to the nervous system. Like you can see here, the simplified version of for the heart-lung system and like the digestive system that will eventually result in those stuff like activities here that we see on the right side. So our goal here is to have some kind of like an estimator that can say what we can have for assessing those kind of like events that will eventually trigger the happy face, that will eventually trigger our specific tone of voice, that will eventually trigger our involuntary like hand movement or like body movement. When, for example, if you're stressed, like we have, or if someone like is lying, like this is, let's start off like from like a lie detector machine. I have received like a few of those like feedbacks throughout the years. So this is where we're looking to focus here, like for specifically on this part. So then we can have like an establishment. So we want to use. So we have this like information that we have here, so we can establish like this kind of like node. And this was, let's say this was provided to us by some manuscript from someone like from 100 years ago. So I have that, okay, so that's cool, but that was kind of like analog signals. As like Josh mentioned before, like before me, there's like analog signals need to be quantified eventually by a computer. So we can use like the word that everyone likes to use these days, so we can classify events into those kind of like categories. So one way to do that is like the dimensional model. And the dimensional model part here goes into like really simplifying any kind of like an emotional reaction into like 4 categories. So you can see here the high to low. So this relates to the arousal. So that's like the y-axis. So this goes into our sympathetic system. How much of our sympathetic system is more active, then we like here more high. And then how much it goes low, then the sympathetic system like turns off, turns the volume a bit down, and then the parasympathetic system like turns off. And then we have on the like perpendicular to that, we have like on the x-axis, we have the positive, negative parts, like in this case. So to refer back to one of your questions, or like one of your notes, so the high to low usually is being evaluated from 0 to 1, and the positive to negative goes like from 1 to -1. So if you've seen those, so this is where these fall. So if you have like the coordinate system that can say, let's say 0.7 with -0.2, so you can find that in these kind of 4 quadrants.
Yeah.
But what I've challenged here, as we can see here, like here on the left side, so I've challenged here to see how we actually lose a lot of the quality signals here when we simplify the system like into this kind of like quadrant system. So in this case, fear and anger, let's say here, for example, fall under the same quadrant here, like in the 4 quadrant. And then it becomes questionable if you can like differentiate those kind of like, let's say, high arousing, like highly negative emotions, like for those parts. And so what we're looking to have here from this point on, what we'll focus on is just like a very simplified approach that what we divide as pleasant experiences. So those are falling under the first and second quadrants, and unpleasant experiences falls under the third and fourth quadrants. So this we're looking to divide a world for like specifically here for this presentation. So starting off with vision, so this is for where Affectiva lives in, up until recently where they got merged with a M&A with a Swedish company. So facial expressions. We have 36 facial muscles that can recreate more than 21 unique facial expressions that we can present or convey our messages without any kind of like verbal meaning. So this is where we're the goal here. So this is where you have like this kind of like Paul Ekman's work, right? So really strong here that can say we have tribunal work that people like living in tribes without much of like of vocabulary can still convey messages based on those kind of like visual and like interfaces when they have like different kind of like facial muscles here. And this is divided here like in specifically like in two categories here. So we have like the geometric features. So this is where we divide the face like into different cue points. And then we have like the level of the smile. So we can say like the level of one smile is like it's by this much, or like in this case, like it's by this much. And we have a different, like let's say, for example, like different emotional category group for those kind of activities there. So this part is known as the facial action coding system, or FACS in short. But this was like challenged, and you will see that like in the summary, like in the next slide. There are like specifically like some really big challenges here, like for applying specifically like for this part. What companies have moved into, and also what made Affectiva unique in this case, is the use of micro expressions. So the micro expressions is the very small wrinkles and furrows that goes on your face that can only happen once you present a more genuine emotion. Let's say we have a smile, so you can so this is like the most basic one. We can differentiate if one smile is genuine versus like one smile which is a fake one. So they use here, for example, like for the micro expression. So we have here where I've marked here, like you can see like here in the left and right, like the wrinkle that goes over the side of the eyes. That will differentiate if a person like is smiling more than more in a general way, like in the like on the other one. So let's evaluate that like really quickly here. So again, with the vision system, we can capture the duration of the emotion. So again, just a reminder, emotion is something that is short-lived from like 0.5 to 4 seconds. We can differentiate between positive and negative ones. For example, the level of like one smile. But then comes the question, like the first one, is this a spontaneous reaction? Is this something that we can actually trust the person that is like doing that? So let's say, for example, I'm doing this smile. And if I have here right now a real-time emotional classification system, then I will have a happy face presented as the classifier. Am I actually smiling? Am I actually smiling because I'm happy, or because like I'm just like doing that for the camera? So this comes like the question here, like, is this something that I'm aware of because I know that I'm being videotaped here, that will will present me or like force me to show like something which is like ungenuine? And so this is like one part, and then this like the second part, which is a more like predominant part, is with the vision system, like based on the level of like one smile, like the level of the smile, or there's kind of like wrinkle system on the face. It's impossible to differentiate an arousal part. You cannot detect like the y-axis, as I mentioned before, in the like the two-dimensional system there. But what you can still use the camera here. So this is where you have for the evaluation of the human eye. So this is just an image for the human eye, and what we have here is the pupillary response. So the pupillary response is an automatic response from the sympathetic parasympathetic relation, or like the activation between those two systems. And this goes between 2 millimeters when it contracts, all the way up to 8 millimeters when the pupil dilate. And this is what actually provides us the ability to both of those systems. So this is why we have those kind of like companies like iMotion have those kind of like it's like special glasses that goes over your face, and then after those kind of like electrodes go over your face that can measure like the different like facial muscle movement. So we can correlate both the valence, the pleasantness, and we can also evaluate like the arousal level, how much this specific emotion is being intensified by the nervous system. I'm getting like a lot of texts. I don't know if those are questions, because if there are questions, I don't know if there is possibility like to give.
No, I think it's fine. You can if we get any questions, I'm happy to put up a poll or let you know.
Okay. Yeah, wonderful. So moving on to so this is by now. So this was like the vision part up until this point. So this covers like for the vision part. So we move on like for the speech and text part. Speech recognition. So this is where we have our vocal intonations, where this is being evaluated, like so you can see, like in the frequency domain here, that we can see the different way that we can like convey a message. So let's say I'm speaking like with a low baritone. Right now, Elizabeth Holmes is like under trial, so they say that she had fake baritone level. So this is where we have this kind of like activities there, and also like with the level of how quickly we speak. This also relates to how we kind of like express our activities. So let's say, so you can say, I mean, even though if it's not true, you can generalize. Let's say, for example, if someone is speaking like quickly, then he's like somewhat nervous, like the sympathetic part is like more active. And if like you have speak slow, more slowly, then you can have that, let's say, as an indicator, like for the parasympathetic activation. But this is like completely untrue. Like there is no basis that can say from one individual that can that speaks quickly that it doesn't mean that he's experiencing like a stressful event. So we can go back and say, okay, you know what? So we can define those as kind of like the vocal tones. I can say. I don't know if I have that here. Oh yeah, I have it here. So this is like the part that actually conveys that specifically how those companies like divide that. If anyone heard about Nuance, the voice recognition company based in Boston, I believe they also recently have been like in M&A deal. So this is how those kind of like people like evaluate those kind of activities. So we have the volume, how quick. So if I'm angry, then the volume of my voice will be like higher. Versus if I'm calm, then I will speak like in a more calm voice. So the amplitude will like be smaller. So this is what we see here, like the definition, like for the speaking rate. So we evaluate like for quiet events between words, as we were saying, and also the pitch. So the pitch is like the base frequency. So when I comprise this slide, I found like really good articles about how we can define the voice and volume levels and like the speaking rate, but it's really tricky, like specifically for this pitch part. So if anyone is up for the challenge, then like feel free to download some voice samples to try to find the base frequency. It's a really good engineer, like if you guys like into DSP and like engineering challenges. So this is like a very good like engineering challenge, like in this case. So this is where we have like voice analysis specifically like for this part. But this is where we have this like mostly it's like an indicator for the arousal system. So as I mentioned, how much like from the sympathetic part can actually contribute to the part. For example, like for the voice level, like the voice volume, like the amplitude here. Then we can see how we can actually correlate that or complement that to have again the positive to negative. So again, remember, we're looking for a way to a two-dimensional part that can provide the computer to quantify more accurately those kind of like experiences. So we can use here where we have this kind of like speech to text. So we actually translate our speech into actual words that can go and say which words are more positive, or like which words are like more negative, or like they have like level of like meaning to them. So this is like really the basis here. And then we can say here, but this doesn't solve everything. So when we use like, so people like to rate. So we have, we go on like on Amazon, like we leave like reviews or feedback, and you have this kind of like rating system, like the stars, like we go like from this, let's say for example, this product is good, to this product is great, to this product is amazing. So we have those kind of like so those kind of like called like intensifiers. So how we can actually describe like different activities and to assign that specifically here like for the rating part. And also what we have to say here, so this is what I mentioned here, like specifically for this part, the use of sarcasm. So I know there has been like some work into researchers to try to identify sarcasm when someone is like conveying that as a message. But this is something that if you're working in this field, then this is something that you have to be aware of, because only analyzing the words as pure words without the vocal intonation. So let's say you analyze tweets. Let's say you go to Twitter, you download some 100 million like tweets, and then use that to build like a classifier to say which were like words like negative, which were like positive. Yeah, these tweets are positive, these tweets are negative, and then you can, let's say, we correlate that like to different activities, like events that happened like during that time. But you don't have the actual use of like how we actually express that. So this is where this is where you had this kind of like missing. So you're missing the like the arousal part. So if you have those, you have the ability to have the, like both of them together, then you can go ahead and say, I can have the better understanding, for example, here, like for sarcasm here, like in this case, because it will be like really hard to the verge of like impossible to use like only words to detect sarcasm. How can you say like, that's so funny? This or a sentence, like for example, where you can say that the same sentence a bit differently, but it will sound like as being sarcastic. So this is kind of like food for thought there. So just like a bit of like summary here. So just like a few, like, so you see here, like a guideline series, like I give like a few sentences here, like for example, how you mark different words that can convey. So happy, for example, can correlate to be positive word, upsets like negative word. This is, for example, so this is like an intensifier. But you have to understand that there is a dissonance when we go on Twitter or on Facebook and we publish a post or like a tweet, like publish tweets. Then what goes on in our head is not exactly what happens when we actually publish the tweet. So let's say if I'm publishing a tweet, I had the most amazing experience while visiting, let's say, I don't know, like some place where in reality I suffered, like I was miserable there like the whole time. So this is like something that like we have to be aware of. And then so he's like the user like of bad language here. So there's something that can take. I don't know if it's common here or like in the East Coast. Like let's say you use like bad words, like the use of coarse words, to actually provide like a positive, like this. You express that as a positive experience or like a negative one. Yeah. So this is something
yes,
that
it can be a special kind of intensifier.
Yeah.
Yes.
Yeah.
Yeah.
And I mean, I just wanted to say that this is really fascinating because, you know, when I half jokingly and only half jokingly say, you know, that we're trying to replace psychiatrists with Raspberry Pi, you know, part of what we want to add to this is this kind of linguistic analysis, right? But capturing all the subtleties of that is really hard, and especially when you're trying to get at like what was the intent. You know, it's not the words, it's the intention behind the words, right?
Yes.
You know, and you know, it's the emotion. You know, like when is it sarcasm? like all of these things are super important for you know. Again, I can show you later a review that Satya Ghosh did on the use of automated linguistic analysis for psychosis detection, right? And you know, like it's not yeah, I mean, it's having kind of like emotional mismatch from when like emotion should be expected, right? You can go all sorts of directions with this. So I just think it's really interesting, and certainly, you know, I definitely want to get at the subtleties of this. Yeah.
Yeah. So this is like really interesting work, and it can only be emphasized by the public access for like OpenAI in their release of GPT packages out there into the field, and how a robot looks. So this is because this is so. I mean, I haven't mentioned that here in this presentation yet, but there are like two kind of like categories out there in the field where we have the purpose for those kind of like technologies for a human-to-human interaction. For example, as you mentioned, Morgan, for like a psychiatrist like looking to treat someone, versus a human agent like a robot agent. They have this kind of like field called social robots, and their need to convey those kind of human-like experience, like emotions, like experiences, into to have a more human-like interaction. So this is all of this work that we will see here is required to have those kind of like feel as a contribution. And even though this is, even though all of those technologies, like let's say they are like solved in like the most like state of the art, the highest state of the art level, then we need to say like because there are like other activities that actually comprise a human being, like being a human being versus someone a robot that can present just like the happy face on the screen and say so they convey like happiness. It's not exactly that. This is not exactly how we humans like interact with other humans. So moving on to physiology. So this is getting closer to what is like my main goal purpose here with my own startup like behind Letos here. So physiology, like a quick recap. The autonomous nervous system. I'm pretty sure. So I know this series of events is like neurotech and like the brain, but you will see that quite like in a few slides. It's like really hard to say how we can have consumer level products that will be as comfortable to wear without much of like obtrusiveness to them, that can actually monitor that like activity like in a spontaneous manner to extract those. So hence my reason to focus here specifically on this part, because there are a few technologies here that we'll explore here in the upcoming slides that can actually monitor all of those kind of like events. Like in
Again, this is absolutely perfect because I believe Alex was asking a question about this today.
Yeah. Sure.
I was, and I got a generic article that described, you know, the mechanisms, but it didn't have the up and down arrows, which is really what I was looking for. So this is very timely, and I'm loving it. Anyway, yes, you're right, Morgan. This is exactly the details I was hoping for.
Awesome. Serendipitous.
Yeah. Okay. So I can see here that I'm missing one slide, but I can just like explain that verbally to you guys so you can understand what the next slides will be like talking about, like why specifically those kind of like the technologies I will talk about. So all of those technologies like the vision, voice, and text analysis, it is possible to capture those kind of experiences in a spontaneous manner. So what I mean by spontaneous manner, so the psychology world, specifically for psychophysiology, like and then like the effect analysis, is divided into two parts. We have the spontaneous reactions and we have the pose reactions. So the pose reactions is what we convey, but it's not our actual our actual state. So let's say we're like feeling like really strong negative emotions inside, but we convey outside to the world like a happy face. So, and then like vice versa, when we experience like really high level of high arousal, high excitement levels, and we want to we express outside like a sad face. So this is like the pulse reactions. And there is a huge debate just by Googling this kind of like two terms, like spontaneous versus pulse reactions, psychology, like you can find that like where like Google, like I don't know exactly which combination, but there's like a lot of work in this field, how we can like differentiate those. And the vision, voice, and text analysis, if we can fool someone that say doesn't know the existence of a camera system. So this is how Paul Ekman derived his initial hypothesis on the base facial expressions that are shared or like as a common denominator across like every geography that we can find out there. Even though they found some tribes that don't have a happy face to begin with, so that they haven't developed that part. But they're like in most cases you can have those kind of like a basis. And the way he did that is he hid behind a curtain or a door with like a small peephole that he looked to see how they react spontaneously without them being aware that he's like watching them. So this is how he derived his initial hypothesis there. The same can be done for voice. I can record someone's voice without it being aware of that. Let's say for a prolonged period of time, with a lot of people, and then we can have some basis for what should be our spontaneous reaction for, let's say, someone who's angry. So I know there is. There used to be they also had like an exit a few years ago, an Israeli company called Beyond Verbal. And Beyond Verbal, how they've come up with their initial data set for like doing the speech recognition part, they tapped into the post office system. When you call into the post office, then they had that for a few years, like 20 years ago, that your conversation is recorded for further analysis and quality control. And they did that to actually acquire those because they counted on that people calling the post office are angry because they're missing a package or something got like misdelivered. So they had this kind of like neat trick how they got this kind of like initial data set going on. So again with text, we can fairly assume that if no one is actually reading what we type on screen, then we can actually say that this is kind of like what we actually spontaneously are looking to express there. So the same way we're looking to see what I'm looking to convey here, specifically in the next few slides, is to bring the same level of spontaneity, like the spontaneous level part, into those kind of like physiological analysis, like here in this case. So this is just like a quick overview. So psychophysiological or like psychophysiological research as a field started off in the early 60s. I believe Stephen Porges was one of the first ones to actually start this as an actual like field, that like a field of work or like field of study. And
Alfredo already mentioned that, yeah.
Yeah, and then what we can see here, like on the bottom, is what specific I'm describing here on the bottom. So this is where we have the most immediate place that we can monitor after the experiences as they happen. So once we evaluate something, then this is immediately processed in our head. So the way to process like in our head, so let's say we use like the fMRI or like MRI system to see like the oxygenation level, like different part of the brain, or like with the EEG signal. So this is before we have even the sympathetic to the parasympathetic reaction. So those kind of like activities like happen there. Then we can move forward. So the farthest we go to the right part. So this is like where we might miss the origination of the experience. So for example, what I listed here, like as the most outright most part. So this is like for the EDA part. So the skin connectivity part is something that can manifest even 5 seconds or more than that in some cases after we had the experience. So let's say we want to use that as an EDA. So the EDA is like the electrodermal activity or like the skin connectivity, SCR, EDA. They have the different notation for that. But the basis part here is that it's automatically linked to our sympathetic system. So when we have the glands presenting like the sweatness on our skin, Then we have a larger activation in the sympathetic system, and we have when this goes away, then we can fairly assume that the sympathetic system it decreases in its activity. But this presents, again, as I mentioned, this can present 5 to more seconds after we had the initial experience. So we can see here, so this is like where we have like in between. So that's kind of like, so EMG is like the muscle tension, like facial muscle movement. EOG is for the eye movement, left, right, up, down. The electrocardiogram. So this is like for the EEG, like this is for like the stomach or like the gut reaction here. So like for this part, but this is where we can like fairly say, we can say like they're looking to be placed as closer I can see here, like to the left part. So this is what we see here. So we will go through those kind of like technologies here. So ballistic cartography, seismic cardiogram, and radio frequency like ultra wideband. So there's the WBAN. So this like wireless body area network. So there's like a different term they get for that, like how they can like monitor like people like with a computer here, like with a computer system. So again, like you're looking to evaluate that. Like specifically for those kind of like approaches there. So starting off with the ultra wideband. So somewhat of like some years ago, I don't know who was the first one to detect that or like to learn about that. But once we move into the frequency range of 60 gigahertz and above, then we can use the radar system or the transceiver antenna as a vision system in case we are in close proximity to the human body. So if you've seen, so analog devices has this kind of like patch that we can place on our skin. And I've seen since then, a lot of other researchers and universities and academic institutes provided sought after like similar approaches there. So we can have this as a high frequency radar system that can look beyond the skin, flesh, muscle, bone, tissue to go into to observe actually the heart, like how it pumps in a really accurate manner. And we're looking like in the same way, like from a distance, then we can monitor like from 10 centimeters to I've seen so 300 meters came from one MIT study I've seen that they managed to do that. So this we're looking to evaluate for the chest inflation and deflation once we have the the intake of air, and again we blow air out. So this is just to measure like the displacement of the chest here. So this like here for for the radar system. So this is like one viable approach that we can use, that we can measure that from a distance, for example here like for the breathing rate, but like not so much we're looking at here so for for the heart rate activity, because a lot of those technologies are required to have like really skin contact or like to be really like a few centimeters away from like one skin. So this might introduce a way that we can actually observe that someone is placing something in front of us. Seismic cardiogram. So this is a technology that you can see here, like it was discovered by the 1960s, but brought into application level in the 1990s. So this if anyone gone into do like an echocardiogram, if you've gone into doing like for pregnant ladies, or like to see if there is something like in your bowel or your stomach we can see that. So this is like the basis for that. So the seismic cardiogram uses specifically for the monitoring of the heart monitoring, is we can see the cardiopulmonary veins as kind of like as a crown. It's a really complex network of like vessels here, and they like pump. I mean, so I'm like exaggerating this, but they pump and pump and go back like in every heart cycle. So then we have this ability. We have this like the placement of sensor approaches that goes over the chest area that can monitor after those kind of like activities. And what I mentioned here like for this kind of like movement here. So this is there is an MIT research. So this is done in 2013, where they used like software magnification of very small movements to detect after those kind of like activities there. This is so they've done what they've seen. So this was initially done to see the blood flow through one's face over the cheeks and the forehead. As you can see that like with a camera system that can go like, let's say for example in the green wavelength, like the green channel, you can see this kind of like a pixel change in their color. I like the pigmentation there, and then we can have that to say we can learn about this that can like very small subtle changes that can be magnified and like to observe that. So this is what happens here. So the same place that happens here. So the left ventricle of the heart can like pumps blood like up to the head, and if you can see, you can sense that by yourself. By so you can say like if you sit there quietly, and you have this like really subtle, like really gentle movement of like your head, like going back and forth. Kind of like those dogs we have like on the car windshield, like the car on the dashboard, they are like moving their heads like up and down. But this is like what happens. So this is like the kind of activity here. So this is like kind of like a cool thing to observe, and definitely look out for those kind of like videos up there. This brings us eventually to the core focus for the technology that behind like levels like what specifically I'm working on. So ballistic cartography is the science where we can use mechanical recoil forces that are being presented by the vascular system that goes throughout the body. So not only in the cardiopulmonary veins, but something that goes throughout the body, like back and forth, like from our toes, like all the way up to our head. That can actually present a very slight like vibration effect that goes into the surface. Let's say where I'm sitting at, like so the most mundane solution for that, and this is where I got the first introduction to this technology. They had those kind of like solutions where someone was lying on bed, and they placed a sensor system there as a replacement for another 12-lead electrocardiogram to monitor patients overnight when you might shift on your bed and the electrodes like become detached. So you can have that as a more robust system. So you can see commercial devices in this field can be, for example, Bedit that was acquired by Apple. So they use like a strip of like piezoelectric sensors that are being placed like under the upper torso part of the body that can monitor throughout the night, like our like heart and respiratory rate. And then we can have that. So this is like when you use like specifically to use that. So this is here for mention here like for the MEMS technology. So this was initially introduced in 2015. So I don't know how much people like for the heart itself. So the heart pumps blood. Heart pumps between 70 to 120. Let's say roughly milligram of like amount of blood at each cardiac cycle. Then you have that, but then you have those stuff like changes, like that's from like 75.6 to 76.1 to have like those kind of like slight changes a bit like between those like continuous cardiac cycles. And the only ability to have that being accurately monitored is if you have a system that can be accurate in the microgram level. So if you can be accurate in the microgram level, then you can accurately measure those like milligram changes that that's happening there. So this was the first step that was again initially introduced for healthcare services that provided that for patients in their bed. And then when I've seen that, then I said for example like where we can have that not for medical approaches, but to have that like a more consumer-oriented approach, like in that sense. So to say how we can relate this to go ahead and go how we can use that in a sense where it can cross-correlate in the field where consumer interacts with products or fields. So what I have this as an initial proposition, that this can be a very good candidate for a spontaneous assessment of the cardiovascular and by result of our sympathetic and parasympathetic system when we're looking, for example, after like the heart rate variabilities like over time, or in this case, because ballistic cardiography also provides us with residual frequencies that can go with additional body parts like body systems that can learn for after other bodily components other than the heart. And we can have that as a spontaneous assessment because this technology does not require to be cuffed like this of like wearable devices. So we can place that on the back of the seat. And so the technology we have right now, so the sensor solution size is 3 by 3 centimeter size cube. I already apologized earlier to Morgan. I forgot that at the place I'm staying at. I'm staying in San Mateo, and I forgot that there in my suitcase when I came here. I had to pack up everything, and I came so I'm staying in Eugene, Oregon for a few months. And when I packed everything to come here, then apparently I left that not in my backpack, but in one of my suitcases. So unfortunately, you cannot see the demo right now. If you guys want, I can send a link. There is an unlisted link on YouTube that showcases the sensor and how it compares to wearable devices. So you can see those kind of evaluators there. This in that video, it goes a little bit deeper to explain how this actually manifests specifically in the the heart-brain relation and how this goes throughout the body here. Yeah, so this the next few slides to show an example application where this can actually provide value in. If there are any questions, any notes, then that can be a good time now. Alex, Morgan?
Yep. In terms of questions or
questions, notes.
Well, I mean, I know Alfredo's had some comments as you've been going along. Just adding supporting material. I don't think anybody's had any questions. I point out that
I will just add that here.
Sure.
If you guys, so there is, so at least at least part of this presentation with a bit more detail specifically on the vision and voice parts. So you can, so there is if you can Google
want to follow up.
And NVIDIA GTC, so this is where you can find this.
Yeah.
There you can find the slides, and I have also listed there open source libraries for the vision and voice part, and also for the text part, open source libraries, books, articles, everything that can help anyone who wants to get into this field.
Awesome.
So they can start playing with that.
Yeah. I mean, you're as we said, you're covering a whole range, right? And we could almost take, we could take one of these and spend an evening, and and certainly I want to have you come back and do that, even if it's selfishly I'd love to come back to the linguistic analysis. I don't know if you feel like that's a strong area for you. I would just want to say that the ballistic cardiogram is something that comes up as a kind of unique artifact when you're doing EEG in the MRI.
Yes. There are studies that shows how you can cancel out ballistic cardiogram contributions in your readings with doing MRI.
Yeah, and it's because you're essentially moving the sensors, in the magnetic field, right?
Yeah, but this actually conveys like more strongly. So this is like an involuntary activity that the body presents,
Yeah.
um,
Yeah.
regardless of like what scenario we're in.
Yeah.
So then so this is kind of like the conveying of the message here. Like this like, can be like an indicator like for spontaneous activity,
Yeah.
or at least I hope that you got that. So like the possibility here like for spontaneous measurements can actually take place. So the mobility sector, anyone who's doing psychophysiological analysis or affect classification definitely needs to look at what the mobility sector has now going on. So cars of today, or the cars looking to be in the near future, will have um, the cameras that observe the road, cameras that observe the in-cabin, that observe the driver. We have the infotainment system, courtesy of Apple and Android and Tesla and whoever they are, like for the voice interaction part. And we have the closest part as we can find for. I will jump like a bit ahead, so ignore what you see here. So this is. If anyone's seen a lab, a psychophysiological lab, so this is how the lab looks like. So we have a participant sitting on a designated chair that is observing some stimuli on the screen, and he's been connected to a lot of different kind of like electrodes. So this is what we use here for example, like in our research in Germany for the scientific validation for the BCG technology as a candidate for effect classification, to have that assay being evaluated in comparison to state-of-the-art medical devices there. So this environment is actually replicated right now in the automotive sector. You have the incoming video feed that presents in real time. So no one, I don't think they actually segmentate like segmentation for this part, like for the scene understanding there, if they're actually using that. But this is a possibility, and I try to collaborate with a Singaporean-based company to go together with them and to see if we can actually present this specifically for the combination of the incoming video feed for cars, because they are focusing on the autonomous part and the outside sensors, and we're looking to suggest from the inside, from the in-cabin part. And this is where I have this. So you know the stimuli, and you have the possibility to evaluate. Let's say you're using any kind of like input method. Let's say you use the vision system as an evaluator. Then you can correlate that. Let's say the person is like talking to Siri or to whoever, like in the infotainment system. And there is right now like a huge trend of like in-car payment system. So you go to I don't know, you go to Starbucks and you can pay with with your voice commands in the car. You can say like yeah, pay for order for me a cup of coffee and like pay for that, and you can drive there and like pick this up. Then you have that ability to cross validate this. And what's like really, so I'll just like go back here. So what's really strong here is the ability to say how we can complement to this part that, again, as I mentioned, like quite early on here, that those kind of like activities are byproducts. Again, these kind of like experiences that we present externally are taking place once our brain analyzes the environment and sent the relevant commands for the sympathetic and parasympathetic parts to like which one should be like more active, like more dominant in like different scenarios. And then you have the external activities. So the camera system or the voice system, they can only observe like the external, like the byproducts. Again, like how I like to call them. And then if we go back here, forgive me for a second. So this is what I can see here. So we have those kind of like really comprehensive approach that can monitor both me as the driver. So you can see here me cruising along. I don't remember where I took this video. Cruising along with my car, and I placed like a few smartphones on the car so I can take different images from inside the car. But you can have that, and it's happening right now, and it will only continue to happen. And this is where you have this, again, like the ability here. So it's like a really interesting field, like a really interesting space that can actually be one of the most commercially available solutions that goes there, like into the market. And so, unfortunately, this is a PDF version because the original presentation size is like 500 megabytes, because this is supposed to be a video, so you can suppose like to see me here like doing something in the car. So like I'm shifting my gaze like from up and down, and this was meant to be like as a mental exercise to have for a state-of-the-art classifier system, like for eyes on the road, eyes off the road, when we're shifting our gaze from the road to something else, where for example NHTSA, like NHTSA here in the US, actually suppose like for you as a driver in a, let's say for example a Tesla, have to maintain your like your gaze all the time on the road. So you cannot shift your gaze, because it's I think it's like for the level 2 part up to the level 3, where you have to maintain your attention level, and by that your gaze on the road. And you can see here in this video, so what I've done in this video is I shifted my gaze like from up and down. You can see like the system classifies between like with my as my gaze shift. And so this is right now what the car manufacturers, they place this, only this part, like can observe the head and maybe the upper body to see your body pose, head pose, to have that kind of a gaze estimation. But what actually happens is this. So this is what usually you don't have inside those cars, and this is like to see the actual the driver like from a side view. So you can see here, you can see me here in this case, like I'm holding a phone, and the question here is, am I attentive enough to what you can see here down the bottom? So it's a bit small, if I don't know if you can see that. So I tried to simulate that. So this is in my parents' neighborhood, where I can like drive there. So like I had my sister like driving, like pulling out with this car while I'm like cruising along here. And the question here is, so I simulated this, but this is actually like a viable case. So what happens is, if the vision system, while I'm ending this part, so I'm looking at this, so it says I'm looking on the road, and by definition, I'm complying with NHTSA or whoever is responsible for those kind of like regulations in this part, but I'm actually holding my phone. So am I attentive enough to what's about to happen if this car will pull out from the parking lot here, and we might crash into each other? So this kind of like activities, the car has to be provided like to have some kind of level of control, like to have some intimate understanding, where me as a driver or anyone as a driver can actually regain control back of the vehicle. So this is, I think I see it here. No, I don't have it here. I'm sorry, I don't have it here at this part. So what you have here, so if you can imagine that, so you can have, so let's say the vision system detects at like some point in time. So let's say we detect the point in time for when we shift our gaze. Let's say it's been detected here, but I'm holding my phone, then maybe at least like take that as a conceptual, like understand like as a, again, like as a mental exercise, that I'm having some precursors, like some physiological precursors that can be detected here, that can provide some insights to the car to say, you know what, this guy might shift his gaze and be like less attentive in, let's say, in some X amount of seconds or like some X amount of minutes in the duration of the car ride. So this is like we have this sort of like strong power that can be provided here, like for example, like in this case. So this is a bit like into this like for the car environment. I only presented that because I had like I chased this as a use case for 3 years almost. when I want to present as a technology like to the market. And this like was one of the reasons why I moved to Germany to be based at where I have this kind of like the German hub like for all those kind of like car manufacturers like Mercedes, Daimler, BMW, Volkswagen, all those car manufacturers like in one place. And so yeah, maybe it makes it makes sense. Like I will be based there. I will provide like the validation studies there. Like, and I was yeah, I can immediately go to, like to those people. But take that as a say like a free advice. I mean, the car manufacturers is terrible, terrible, terrible start for an early stage company. I can have a completely different session about that. I know it's a lot of out of topic, but I mean, take that as like a sign there. So this is where I say like it's like an extension here. So again, like so the driver is sitting in the car, and this is where I would like to pick your interest. So I will try to draw here, and I hope that you will be able to see that. So again, so this is the lens arousal. Everyone can see that? You can see the drawing?
Yeah.
Is it visible? Okay. So again, so do you remember this? So this is the two-dimensional system, as we mentioned before, earlier on.
Mm-hmm. Yeah, the four quadrants, and you mapped all the emotions
exactly.
to one of the four.
Exactly.
Mm-hmm.
And now, so for here for the attention part, so you can, so this is a study by a researcher named Matthews. So this is like the last name, and she did a study where people hold phones and to measure their attention level while they're holding the phone, to see their attention level. So like for like do some like levels part. So this is a simplified part. Specifically, I've extracted this, the bottom image. I've recreated that. There is a book, I think like in 2011. If anyone is interested in that, I can say you to like the name of the book. And they provided their like five levels of attention. So this is where I have so like the ignore, the make aware, and the demand action. So this is where you have the car system can like ignore the situation because I'm attentive, I'm holding the steering wheel, I'm looking on the road. The make aware part where we might have some actions that might be considered as somewhat dangerous. And then for the demand action where the car says, I'm reaching an obstacle that will require your immediate attention because there will be a non-0% chance of like an accident that will take place. And now I will try to draw here like the thought experiment here. So we have here, so there's like the valence arousal system, and then we see here like for the attention part. So I will try to draw here kind of like a parabola form, and you see that here. So then we see here. So this is the probability of an error in attention reaction. So everyone sees this? Yeah, okay, cool. And then we see here, so our utmost ability to maintain attention is where we're here. When we don't experience much positive, much negative, and our arousal system is somewhat being regulated. So this is where I have the utmost focus part. So this is where I have like products that can say you can listen to some tone or like some music, or you can focus, like do some drill. So this is where they're trying to place you here. What happens is we start to experience, because we're not robots. Again, you have to remember that we're not robots. So this is like described here. So we have the tasks that we're doing. So in this case, it's for the car, but it can be in other cases when we're in the office or in another environment. We have a set of tasks, but we're also humans. We have our own brain, our own thoughts, and our mind can drift. And if your mind can drift, then you can recollect experiences from the past. And this is where it goes back here. Again, you have to remember this. So our motivation experience is being divided or being categorized in our head in positive and negative experiences. And our brain recollects that and recreates that. And then we go back here. Oops. And then we go back here and say, we experience that here. And then our attention starts to shift for the car that will start recognize that. So we have this, if we have this kind of like increase, like in the positive part or in the negative part. So what I'm trying to, so I don't have, unfortunately, I don't have, I've seen some studies, but not a lot. But this is something that I'm definitely looking to explore in like in the near future. If we have the increased positiveness or the increased negativeness, then this would increase the probability of an error in our attention, like our attention span.
So, you know, I know it's a slight aside, but, you know, I find it interesting, the overlap between what you're doing and computational psychiatry, right? And you know, like Yale Niv's work at Princeton on computational psychiatry is really actually getting at, you know, trying to subtype depression by motivation. You'll be interested to know. And so giving, anyway, these absolutely add an important, you know, an important dimension that, you know, hopefully you are using kind of multidimensional information to get at this, and it will cut down on your, you know, on your, I mean, it will improve your entire ROC, you know, performance.
Yeah, so this is where I have this. So to relate to neuroscience, so this we have like a competitive part where we are happy because we got promoted at work and we are super happy. And our ability to make an error as a result of that will increase. And again, with negative parts. So when I was working in Germany, it always gave me this example. Always give me this example. When you wanted to have this, and you will see that in a second for how we've like the basis of our comprised like this experiments we've done there. They had this kind of like example to me when I came there initially. When you're hearing the sound of an ambulance or a police car siren, then this is a very aversive event that you try to avoid. So there's like a strong negative experience that happens like quite immediately. And then it provokes like a set of reactions that every little noise or something that goes in the car will immediately shift our attention to it. So this is where you have this kind of like where you have this kind of like value. So why do we need affect classification in the wild? Like where does it make sense? And you kind of have those kind of like activities where it makes sense. So you have this kind of like, you're controlling a car. It's a heavy machinery vehicle that can unfortunately can hurt and God forbid kill people because we lose attention here, like here in this case. So this is just my way of like saying like where this can go. Like we have like the foundations, we understand like where this is coming from, and where this can be like applied, like how it can be fused like into other fields there. So just like so this is like a bit of the work that we've done, specifically in how to scientifically validate like the sensor technology. So again, I've shown that before. So like specifically with this slide, we are like 8:48. I don't know how much time we still have.
One thing we're not is timely.
Yeah.
But that doesn't mean that you have to go long. That just means that as long as you're having fun, we can stay here. And as soon as you run, okay, because I have a bunch of questions. But like I said, so don't worry about the time. Worst case, we'll cut it at 9:30 or 9:45 at the absolute latest.
I might duck out because I've got to read my daughter a story before bed. You're good for now.
Okay, cool. Yeah, so as I shown this slide before, so we had participants coming in. We brought a group of 65 people in the ages of 18 to 35 years old. The geography was because it was in Germany, so like most Western European. So maybe like mostly German, but there's like the population might also include like Italians, French, whoever like comes as student like to come in that goes there and might have been like part of the study there. Most like the 70% female, 30% male in terms of like that kind of like diversity there. And we used this kind of like so we had like 1, 2, 3, 4 or 5 different kind of like sensor systems to evaluate those kind of like activities. So we had skin conductivity response on I think they had this like on the fingers. They had electrocardiogram, so that goes on the wrists and on the left ankle for the third lid as a ground lid. And we had 2 different even three different sensors like sensor inputs over the person's face. So one of them was the corrugator to see for agitation, if you have this kind of like you were like being agitated by something. Then we had here on the sides of the eyes like for the eye movement, like if you're looking like left, right, up, down. And then we had another set a little bit below that can see like for startle events if you're being surprised. And we had this kind of like a auditory channel. We have like headphones over the test participants that played like this different sounds that can like increase or decrease their arousal system. And also like every now and then the guy who facilitated the study had this like a very high-pitched voice. It was like a very split-second sound that provoked like a surprise, like that forced you to do this like a like flinching event. And then I had this like I tried to like to see if we can like reset that, or like to have some kind of like reset for the nervous system reaction there. So we had this kind of like 4 different sensor inputs in comparison to the in-seat sensors that went. I think if I'm not mistaken, they were placed somewhere here on the right side of the chair to have like the most up like proximity like to the chest area, that have like the strongest signal to be picked up. And then we use like and then we used here for this case, we used the stimuli that went on the screen. So those were like different images. So like pleasant images, so like unpleasant images. I believe the comprising of the study was from the IAPS image source, or like from that part. And then we presented that. And then they also presented something that was like an imagery task. This is, I think, this is explained here. So this is like for it had like the perception part. So this is something that like for viewing, listening, or reading some text on the screen, and have to have that kind of like a stimulation, like for this part, to see that, to try to provoke pleasant and unpleasantness in the participants. And also here in this part, like for this, like I mentioned before, so this like the imagery part. So this like to try to give participants like an imaginary scenario to guide them through. So they gave this like as one of the examples where you're about to give a speech in front of 1,000 people, and to see for like the go no go situation where you have 30 seconds to give the speech, you have 20 seconds, you have 10 seconds, 5 seconds. And then you have to give it now. So to try to provoke some imaginary event, like some imaginary experience, to see how, like to provoke the reactions here, like there, and like in that case. Oops, sorry. So this here again, like a bit of like a summary part. So like as I mentioned before, 65 participants. We had both the wearable solutions, like in comparison to the contactless system. And we wanted to evaluate kind of like the limitations, the variations, the accuracy. There's like, why it keeps close, like trying to the multi-window solution. So there's like a bit of like a post analysis to see how accurate the ballistic cardiography is to the electrocardiogram system. So soccer physiologists for assessing effect in this case for purely from the heart reactions, it goes with IBIs, like the interbeat intervals. So this is what we see here on the y-axis. So you can see here one. I don't know if this is a bit small. So this is one. This is like 1.1, 1.2. So it's like 1 second. So like in seconds, I have this. Between, let's say, for example, like 1.3 to 0.7, roughly speaking. And this like even being like those have like a continuous heart measures like being fluctuated over time that will correspond to different experiences there. And you can see here, like for example, here in this case, where we managed to pick up some of the events that can be closely correlated to the echocardiogram. So I won't go into specifically deeper into the analysis. The guys there published a paper. I can share the link for the paper so you can see into more detail the study, how it was comprised, the results, like for analysis, how those kind of like activities go into into fruition there. Yeah, then so this is so that was fairly quick. So this is like the end. That's it. This is like the end.
That's
Yeah,
awesome.
that's the end.
That's awesome.
Yeah, I mean you can open the stage for Q&A and open mic if anyone is up for that.
Yeah, well, for sure, and whether you're here or obviously we'd make accommodation if you're back in Germany. We're going to want to talk again.
yeah, I would love to. I mean, I can talk about this like for days.
Well, I mean, I think the driving example is going to be really interesting to a lot of people, right? And some of the certainly, hopefully next week, Jody's going to join us, Jody Mishra, but other people from Ghazali Lab have joined us, and NeuroRacer was their driving game that was getting was focused on really getting attentional effects, but having, I mean, the only thing that you're not doing is EEG, and honestly, you could add it.
I mean, I have to say that we did have EEG, but unfortunately, we got a grant. Why is this showing like the multi-windows? We applied and got a grant from the German government to do this kind of like study, and unfortunately, the finances to purchase equipment went through the university.
Yeah.
And they took a lot of time in procuring the equipment that we needed for doing those kind of experiments. And unfortunately, the EEG part came like 6 months into the study. So we missed like a huge chunk of the group with the EEG part. We decided to exclude that from the experiments. But this is, again, a bit unfortunate.
It would be great to have, but as well to also see what the contactless is able to do against these kind of like these wired measures, right? And and again, like there's such a history here in terms of this kind of attentional work, whether it's driving, whether it's flight, fighter jets, or whether it's radar systems. The Defense Department also puts a lot of work into, how can I tell if a person is really paying attention, right? And that person's really aware of their surroundings, right? So Scott McCaig of EEG Lab fame, among others, many other things, really started doing his work on radar system, radar operators, and the kind of attentional work that the Navy cared about.
Yeah, I mean, definitely. I mean, I can just like add that as at least like as an end note for me. I mean, if you're in the audience and you're listening to this right now or as a recording, if you're a researcher, I'll be glad to hear from you. If you're in some market, like I'd be glad to see. I'm basically looking for collaborators to present valid use cases for those kind of like contactless solutions. So I'm open for that. I mean, I came here to the US a few months ago. I worked with the University of Oregon, so I stayed in Eugene for a few months. I don't know if there are any Northwest people in the audience or in your group, because it's quite different. The weather is quite different from here in California.
Yeah. Well, so Diego's not joined us this evening, I don't think. But like I said, like I lived in Eugene for a number of years, and unfortunately, Philips bought the company I worked at, and then it's been sold on to MagStim, and they've moved everybody to Minnesota, I think. But Don Tucker and Fan Lu are still there in Eugene. So, I don't know how much time you're going to spend more in Eugene, but Belco is the company to look up there. And but I'm really interested in these driving driving simulations, or we want to put people in kind of scenarios more. I mean, certainly a big part of NeuroRacer was giving people a more realistic lab experience, right? Or and again, like certainly adds a continuous performance task. Right, so that was NeuroRacer was essentially adding traditional psych task. I think it's like delayed match to sample, or to a continuous performance task, staying on the road, right? And then you're waiting for these signs to appear, and that would be kind of like your event related design. Really interesting, and when they were trying to do work with older adults. These are like healthy older adults, but 75 plus. They're looking for changes in the EEG that would correlate to differences in the behavioral performance and things like that. And honestly, I think not having a lot of the other physiological measures might have helped. In getting at what I think they wanted to get at, which was things like attentional issues, or teasing apart some of the. They found some interesting things in terms of reaction time performance and things, but the way, like, it was hard to get the EEG to say something new about that you couldn't get from kind of computational analysis of the RTs alone. And I wonder if some of these other kind of physio and more autonomic responses could have potentially been more informative, but really interesting. And Alex, I'm sure you've got a whole host of.
Oh yeah.
I have maybe before you start, Alex. I mean, have you got a better understanding of what affect is? I mean, because this is what my goal with this talk.
Yes, really, I would like to find a good overview of the relationship between the parasympathetic, the sympathetic, and the causality of the symptoms. Because, I can find a lot of descriptions of, when your pupils go up, that's, the parasympathetic, sympathetic. I don't find a lot of explanation of what exactly do people believe is happening. Like, we do a lot of esports research. So yeah, to answer your question, yes, but the question that I had is a little more specific than just like what is the sympathetic, parasympathetic. Like it's really to try to understand how they relate to either performance or how that relates to the experiential part.
Yeah, so So you have you have to think about your body as to have somewhat of like three brains you have in your body. You have your brain, your actual brain.
Mm-hmm.
You have the heart, which is, I mean, every body organ. Sorry about that. Every body organ is connected like through the cranial nerve, to the vagus nerve, like here in this case. And then you have like the heart as like an evaluator in this case, and then you have your gut.
Mm-hmm.
And there are a lot of studies like on the brain gut connection
Mm-hmm.
and how those manifest like in those scenarios.
Mm-hmm.
Then you have on the other side, you have I think Guyton is the father of this kind of like a medical field, like for specifically for in the sports healthcare, because a lot of those companies, like for example, like Elite HRV is one of the famous ones. I think they're one of the co-founders based in Vancouver, and the other guy, I'm not sure where the other guy is based at. And this is where they stem from. So they stem from how to use Guyton's work and to bring that into the consumer world, to have those kind of like devices, like wearable devices and like their own wearable devices. And you can question about like the accuracy of the device. If it is like the accuracy of the measurement, they have this device where they measure like the finger pulse, and you have this morning readiness test. If your HRV score is X or Y, and if X is like let's say X is lower than your usual HRV score, then you're not supposed to take any heavy like athletic activity. Specifically.
Absolutely. Yeah, the Whoop app does that too. There's a recovery percentage, and they base it off your heart rate. And so I believe that your heart rate is elevated when you're in recovery, and it returns to normal, something like that, right? Or maybe I have it backwards. But whatever the case, they can detect.
Yeah. They have this famous. I can draw that here. So the diagram here. So let's say this is.
I'm going to close your presentation so we can see your screen better, but that's only so we can see the drawing that you're doing right now.
Yes.
In other words, now you're on camera, right? So go ahead.
Yeah. That's wonderful. So we have this here. So we have some let's say some baseless. So they have the racing heart rate. So they have like a 24-hour heart rate, and let's say this is for example, let's say this is 60. And so this is actually what I based on the work what I've done with the guys at the University of Oregon, to have early predictors for like an infectious, when you contract an infection and how it like reacts there. So once you have this like event, a stressor, and no matter if the stressor is due to a disease, because you had a bad day, because you haven't slept, if you missed sleep, if you drank alcohol, that can also be some kind of like a predictor there. They have like a stressor, and the stressor results in an increased heart rate. And that goes into some level, let's say 65. So it goes up here like to 65. And then your body goes back. So this is an involuntary reaction. So this is when people say, I can detect emotions with psychophysiology. I will be really judgy or bullish with a guy who will make that claim. The main reason for that is what happens here is once your body goes into that level, you cannot stay in that position for long periods of time. It's not. You will age a lot faster because of that. So your body tries to go back and try to manifest something that will go back into your own baseline. So you try to go back here. So this is where you have a healthy sympathetic to parasympathetic relation. And this is involuntary. This part happens without any cognitive or conscious brain intervention. This is your own body reaction to fuse back into a last known state. Think of it as like the recovery system, like in Windows. You say like recover back to some known state I was good at. So that's what the body tries to go back to, and this happens like regardless of that. So you can say I'm like in this place, but your classifier system will say, okay, so this is because of you had like some negative experience, but it doesn't have anything to do with that.
Sorry to. I have a very specific example I'm thinking of that I haven't articulated. So if we can just talk in that context, it'll just be a lot easier for me to understand. So pupils are the part that's interesting to me because pupil size is a measurement that we look at a lot. So we'll see a very similar plot. Let's say in a first-person shooter, if someone's in a room that's safe, their pupil will be at some baseline level, right? Let's say in this scenario, it's the 60, or it's 6 millimeters, right? Let's just say millimeters. So 6 millimeters. So when they're about to do something that's dangerous, like in other words, they're about to go around a corner, there's going to be an increase, an anticipatory increase in their pupil size. If they see an opponent when they go around the corner, then there's going to be a spike. Okay, and that spike in pupil size is going to keep happening until they're actually actively in the firefight. So they've engaged their opponent, they're shooting at them, and that's going to be kind of our peak. The moment, and I'm talking the millisecond that person gets killed, we'll see one of two things: either just a drop on its own, or the other funny thing is blinks always tend to happen right after an event has passed. So like it's incredible. Like the guy drops, and the next frame we get a blink. And it's like, okay, so that was being held for this moment. But it's incredible how fast the eye sort of tends to recover to that baseline level of what you were in the room. It's really responsive.
Yes,
so,
and that recovery stems from this.
Okay, yes.
This recovery stems, this is your heart. As I mentioned, you have two brains. So your brain, your heart. So your heart cells as a representative of your sympathetic system stop doing that, because that will drain your body resources, maintaining that, because when your pupil dilates, so this is like a sympathetic activity.
But is it the fact that your brain? I'm having trouble parsing what's driving what. Is it that your heart knows that your brain wants more resources? And I'm sorry, I'm asking in such a colloquial way. I know Morgan's like cringing, like, oh god. But like, is it that because cognitively you're going, oh, an opponent, I really want to shoot him, and like your heart goes, oh, I'm in a high load situation, allocate more resources? Or is it like the pupil is driven by the cognitive state? Like what causes what to happen?
So you have so cognitive activities are set aside. This fight or flight response that you're talking about, this is a visceral reaction. This is your body organs having their own somewhat of ability to make judgment, so they can initiate quickly, because you don't have let's say you have your computer here and you have some remote server. You don't want to have a life-threatening activity.
Right, that needs to go to the cloud and get processed and come back.
You don't wait for your brain to analyze what's happening to have the response.
Right.
You want some immediate responses, and the pupil dilation to get like a better image of, if it's the opponent you're talking about, to get a better image of that. So that's immediate.
Okay, great.
And I mean, just as a bit of or certainly a personal example, right? Because we just went through this haunted house down in Santa Cruz,
Okay.
and sometimes a flashbang will knock me into that state, and sometimes it won't.
Wow.
And I'm like, I'm not capturing enough data about myself to know when that but there's something going on there that's not conscious, right? And yeah, like we would love to get further at the root of that, right?
Okay.
And certainly this comes up again, speaking more from psychiatry. We want to know what causes that dial to shift for people into the oh god, danger, right? that's one of the symptoms, certainly with PTSD or something.
We accidentally. Oh, I'm sorry. Please go ahead.
I think he had.
No, sorry. You go. Rafael.
I can. I don't know if Alfredo is still here.
He had to. He apologized and said he was taking off unless.
Yeah,
So-
because I mentioned Stephen Porges in my talk before, and he's like the father of this work. And Alfredo had like we had like a few exchanges about like Porges' work and how he uses like the digestive part, like the parasympathetic part, as a reaction to the dangerous event. Because sometimes you don't have a fight or flight response. Sometimes you have a state which is like a third state, like a freeze, when you actually stand up. Yeah.
Right. I mean, as another, to add complexity to it, right?
Right.
And where is that decision making going on? I mean, is that your question, Alex? Like,
Yeah, okay, so let me give you two slightly contradictory examples. When a game is going normally, when it's kind of flowing, there's these gradual changes in pupil size that kind of track with what's happening. But since that was one of the first sensors that we got online, I started, most of our data I interpreted through the pupils first. And it didn't have any other way to look at the heart rate or the respiratory rate or the gut activity or anything like that. So it was just, here's what we got on pupils. And so I have this mapping of, this game state generates this pupillary response. And over time, it seems like very, very clear that you can infer that it has to do with how much mental activity is going on, how well prepared the person is for the next state, and sort of like what the next state is. So when people are getting in a fight, their pupil size goes up. When they finish a fight, it goes down. The more they feel like something requiring their attention or focus is happening, it goes up. And then, the more that it's boring, as soon as they die, it goes down. If they're in a dead period, it goes down. So I kind of understood that sense of it. But then there was another incident that we had where it was recording a driving game, and somebody thought they were about to rear end another vehicle. And so we saw this incredible pupil size drop, which was really not what we expected, because usually when something is about to happen, we see a pupil size spike. And actually that drop was one of the most precipitous drops I've ever seen. It seemed like it happened in a flash, and the pupil size went from 5 millimeters to like 2. And obviously I've never done pupillometry on someone about to have a car accident, but it looks like something really interesting happens. And I would love to get your take on these two contradictory. Morgan's got one. All right.
It's funny. It's fun. I mean, when we were talking about Eugene and people that maybe you should look up when he's there, I mentioned these eye tracking people, and I think I got looking for eye tracking people because of this thing that you were talking about, Alex.
Right.
And we were talking specifically about like norepinephrine,
Right.
And like what system is controlling at least that,
Right.
And
yes.
And do you want to speak? Well, let me let you talk, Rafael.
So again, like the activity you saw there for the immediate decrease, that's Porges, and I implore you to read his. He has this book.
I will. No, after tonight, I definitely will.
The science. The neuroscience. I don't remember exactly the name. He has a book that was published 2010, 2011, where he's like basically got like a comprehensive review of his 4 decades work into like one book. And fair warning for anyone, like for you, anyone here in the crowd, trying to read that, it requires a lot of like medical background. I mean, like a lot. I mean, I was a pre-med before I went into engineering, and I've gone into a lot of like in the recent years, I've gone a lot into those kind of like research studies, but still I have like a few topics there, like beyond my understanding there, how those kind of like, he has really like a really good chemical reaction, what kind of like reactors, kind of like at which point. But the one thing that goes constant there is his polyvagal theory. and how you have a third state. So people know the fight or flight or the rest and digest. So like daytime, nighttime, like more or less. He presented a third state that he envisioned from reptiles and lizards. That they had, you see them and they see you like in the freeze. And this is something that puzzled him. And then he projected that from that to humans, and then he gives like a really convincing argument. His work like is really detailed. How those kind of like manifests into humans, and then what you saw there is a live example of his work.
Oh wow.
So again, this is an involuntary, unconscious reaction from your visceral system, trying to react before your brain goes into action. Because again, you have to understand that to activate your brain, that costs energy.
Right. Yeah.
You're trying to maintain efficiency here.
Yeah.
Exactly. We got.
I mean, unless you upload your consciousness into some like remote GPU card
Kurt's
farm,
wild. Kurt's wild. So just to clarify, what you're describing is that potentially when people are about to have a car accident and they're aware of it, a lot of people have this freeze third reaction that happens, or that was just one of them being captured in the wild. Like, how would you describe it?
Not everyone will present those, but some people will present these kind of activities. And I'm pretty sure, I mean, if I will look back, and I'm pretty sure anyone here in this session will look back on his life, like different events he had, and you most likely had some events that you had some non-zero amount of time that had like no action to do. The experience shocked you so much that you just like stood there. Just like, for example, like stage fright. People like stand there, freeze, like what do? You stutter. And then this is like what you have here. So this have a kind of like so when you go
but like that's more of a social buildup. I'm gonna give a speech. People have this anxiety that they won't know what to say. I think it's a very specific learned behavior. I guess I'm saying like the momentary freeze. I get like the deer in headlights, or you around the corner and you see a car about to hit you, and you don't know what to do, and you stand there. Like, are you saying that the two are quite similar psychologically, though?
I would say that you can have some basis. Once you have progesterone in your head, then you can start to demystify some of those events. Because whenever, so when I go right now and I will read a new paper in the field of affect classification, like in the first sentence there, I will know if the writer knows what he's talking about, or knows what he's talking about, who doesn't know what he's talking about. And then like it screams in my ear and someone says like complete nonsense. And then you can see like in the first sentence, like in the first paragraph, like the first introduction. I will do like an emotional recognition system. Again, this is not how. So this is where engineering came, and I have the. I mean, I'm an engineer. I have the utmost respect, but they try to force the engineering on the psychology, and it doesn't happen.
Right.
We're not binary in our behavior. Right. This is like a non-linear connection that happens like completely random part, and so you have to say, what can I still say? So this is where we have here, like in this talk about like the pleasant versus unpleasant, like to have this two core basis that you can like fight around with. And there is also support. There is a researcher from I don't know from which university, Lisa Feldman-Barrett, if the name popped up in one of her meetup earlier before me. I can type her name here. And a lot of the learnings, she got it right.
Oh wow!
She got it right. And I will also recommend people to read Levinson. I think he's still working. Like Robert Levinson from Morgan, help me here. He's from UCLA, UC Berkeley. Robert Levinson, I believe his name is.
Let me check.
Uh,
I'm not sure.
and the paper
Okay.
was 1987. I can send it if anyone wants this PDF. And he presented that question in 1987, where when he brought like test participants into his studies, and he said like the first step you say try to clear your head from like their thoughts or like whatever, try to be like in a place of like a baseline. So he basically questioned the existence of a baseline. He said there is maybe there if there is a questionable part that because this is something that's really amazing. So you can say how do I let me share the screen for a second.
Yeah, you can hold on one second. Wait, I don't even know how that got disabled. Because I don't even. All right, hold on. I'm gonna share the screen. No, you got it. Perfect.
Yeah, just a second here. Sorry, Morgan. Sorry if this is something that. So you have here. I think science and on science maybe. Let's see. No, that's not good. I will draw it. Man, it's click. Let's stop this. So I'm going to draw it here for a second. So we have the heart, and then we have the SA node that we have the vagus nerve that's being plugged into, right?
Mm-hmm.
So this like goes here, like this is the brain. If we disconnect this, and you see that in open heart surgery, and you connect, you're going to plug, once you implant the heart without connecting the vagus, like without connecting like the vagus nerve here, then you have automatically a 90 beat per minute. And this is what I always like to tell people. There is no constant heart rate to someone. Your heart rate, once you connect the vagus nerve, is random. This is alive. This is dead.
Right.
You have to understand, like this is part. If you don't connect like the brain part, this mean that your brain is like disconnected from the heart. This like mean that you're either brain dead, and only your heart is like pumping. But if only the heart's pumping, this have a constant rhythm of like 90 beats per minute. And then once you connect like the vagus nerve, you can if you like surgically connect this to the heart, then you start seeing a constant random rhythm for the heart.
Mm-hmm.
And this is the brain communicating with the heart, and the heart communicating with the brain, whatever the heart is like reviewing there constantly. And this is like the reaction. And those kind of like interplay, slight changes, increase sympathetic, decrease parasympathetic, and this happens like all day long, because all day long we are experiencing stressor. We are experiencing like stressors like every day, every second, every minute. You're experiencing a stressor. Someone is calling me on the phone. There's like a message, like a boop, like a blip. That's a stressor. You react to that.
And the only, it's just in a video game, some of this stuff gets a little more abstract for me, because I'm like, this is a pleasurable activity that people choose to do, and it's ultimately safe, even though it feels engaging when you're doing it. There's no actual risk to you. And so in that sense, and I've always had a difficulty reconciling, when we talk in these evolutionary terms and we talk about physical health, I get it in a real world setting. And obviously it applies to games because, we embody it. I totally get why you get the same responses, but it feels like there's an element of skepticism somehow on my, or not skepticism, like somehow I don't know how the two necessarily go together, but it sounds like basically there's no reason. Like it's, you get the same thing. Oh, sorry, please.
Well, I mean, I do. I mean, we're not going to fully solve this, right? In this sense, just because, you know, this is a really open question, right?
Okay.
Why does a reduced heart rate variability increase your risk for heart disease and death? Right? Or, like, why are you more likely to die because your heart rate variability is becoming is lessening? And you know, it's like what's the right term? The $6 million question. That's the $6 million man, right?
Gotcha.
But I mean, there's a huge amount of money in this, in that you know, in the sense that, like, there are jobs for this if you are interested. And you know, the way it was presented to me was like, you know, a lot of these people who are high risk have really well-paid jobs, and so there's a lot of money in this. You know, like, there's a lot of money if you want to look at this, because, you know, these are like bankers and stockbrokers and you know, and people who are living high stress lives,
right?
You know, 24/7, right? Not exactly, but there isn't a good answer, because if there was, these people would be, you know, taking whatever it is that they could so that they don't die at 50.
So they increase their variability. And actually, so thank you very much. When I asked about these parasympathetic, sympathetic, you know, I don't really have any way of knowing the complexity of the question that I'm asking ahead of time. And so, but I think that's a wonderful answer. I really appreciate it. So can I sneak in 2 super quick questions related to stuff you presented, not the theory of...
But let's do kind of wrap up, just because I know
30-second questions.
I've got small children that are trying to sleep.
Okay, cool. Where can I read about this organ vibration?
No. That's just the visceral. I mean, that's blood moving, and your guts aren't your guts aren't solid. Like, this is the most.
Which organs vibrate at which frequency? How do I find that?
Every organ vibrates at random frequencies. I mean, they have some distinct frequencies, so you can differentiate.
Yeah.
They're not vibrating on their own, right? They've got
like motion-induced resonance or something.
Motion. It's you've got a set of tubes, right?
Mm-hmm.
But those tubes are soft.
But they have a frequency to the vibration. I just never knew that, because I mean, your brain oscillations have a frequency.
But it's a physiological. These are physiological frequencies.
Yeah.
Okay.
This is primarily driven by the heart, but also your guts have some peristaltic action and other things, like you know. I just don't
not like that kind of vibration.
No. It is very much biological frequencies, right? And this comes, or, you know, and again, like, the only reason I mentioned the MRI is that we get these beautiful images of, like, I don't know if you're familiar with what durian is, but, you know, the durian.
Oh, yes.
Like, we get these beautiful images in the MRI of durian, the fibers and things like that. When you try to do the same thing of the guts, right, it's kind of hard, right? And that's because they're not staying still for
right. They move, and an MRI, if it moves, it's fuzzy.
And the motion that we're missing with our eye, the MRI picks up in basically loss of signal contrast. You know, because of the. Sorry, I'm moving my hands out here, not the camera. You know, and that's what we're missing here. So this is why in the MRI I don't do this a lot, but I know of this from people who are doing the heart and they're doing the guts, is that they'll do things like, okay, I'm gonna image your heart now, like, stop breathing.
Right.
You know,
right.
And or they're actually they're doing ECG in the magnet so that they can capture the heart at a particular beat.
Gotcha.
You know?
Right. Makes sense.
And so this is all biological, right? But again, like the kinds of things that the video is picking up of, like, you know, video can capture my
Mhm.
pulsation and things.
Mhm.
Like in the magnet, you know, these metal sensors, because they're vibrating or because they're moving in the magnetic field, they're picking up. You're getting all this again this signal artifact, and it shouldn't. I mean, the reason that we're using Alex vibrate is really just saying that there's this oscillatory activity that you can see in the power spectrum, and
Can you
what I
assign a
wanted
frequency to it?
yes, absolutely, and
So
so
where can I see what is the measured frequency of people's organs oscillation?
well, more important is what's the power spectrum of the electrical activity of the gut neurons, right?
Okay.
Because that's super interesting. And like again, what are the gut neurons doing different than your brain neurons? Or like and
Right.
and you know, if they're neurons, right? Like we say this as if it's a cell type. It's not a cell type. Right?
Right.
Like
Right.
there's a variety, right? And what we really want to know is how transcriptionally are those neurons, or, you know, in terms of gene expression, how are those gut neurons different than your brain neurons? And this gets a little bit to Joshua Bach's talk about AGI as a philosophical enterprise, where somebody asked him a question about microbiome, and he went off on this, I think, really interesting idea about like that your gut neurons are really involved in kind of agriculture of
Right.
your microbiome. Let's call it what it is an open question,
Right.
right? That we haven't got enough data on,
Right.
but what I do want to mention is, and I'll dig up his name, but there's a new guy at Stanford who's doing EGG, or electrogastrogram, and so yes, it is egg. But two things really interesting about that. One, because nobody makes EGG equipment, he's super interested in low cost EGG equipment that he essentially has to manufacture. So I was just like, well, you're gonna love NeuroTech.
Yes.
And so I think that's really interesting, because like he cares if we can build him a better, you know, mousetrap, so to speak. And two, like, he's one of the only people who's actually collecting data about this.
That's so cool.
Instead of speaking philosophically about what your what your gut neurons are doing and what relationship they has with your microbiome, why don't we collect some data? And so this is the guy that's actually doing EGG, EEG, right? And getting samples from your microbiome, and like maybe we will get some answers. And like, honestly, he's one of the only people I know doing this kind of stuff. A really fascinating talk that, again, I will try and find, and if I don't post here, I'll post in Slack. But I do want to try and wrap up.
Oh no, I'm all good. I won't stand in the way of things. So yeah, let's.
Think Sasha's asleep at this point, but I want I don't want to wake other people up, and so thank you so much. I mean, yeah, we're going to have you back, or and even if you're in Germany, we do a separate European time call for those in Europe. So our morning is your evening. So it's absolutely possible to keep in touch and for us to do this same thing. And please, follow, like, get on Slack with us, and because I'm sure there are more questions. Live isn't the only views that this video is going to get. So, I would expect that once this is actually on YouTube and it does get more views, there are going to be more questions. And yeah, really hope to continue the discussion because this is all super interesting. Yeah.
Wonderful. I'm happy to hear that.
Okay.
You have no idea how happy that makes me feel.
Good. And thanks for bearing with us on the technical issues.
Yeah, luckily we got it sort of working.
First time, yeah, I've been I've been at a talk in my own house. Somebody else is in my chair, but that's cool. And yeah, so and you know, again for next, well, so a couple of things I want to say. So one, hopefully next week we're going to have Jyoti Mishra from NEAT Labs at UCSD.
Mm-hmm.
Talking about her work. I don't know what she's going to emphasize, you know, but she certainly does EEG and fMRI. She also does wearables and you know, digital medicine, which is you know, you could call computational psychiatry. She is in the psychiatry department, so she might actually call it that. But it's certainly getting more information from behavior and using computational models. Should be whatever she chooses to focus on. It will be fascinating. And then on the 11th, we are going to have our first winter social. And so we shall be, that'll be the evening of the Saturday, the 11th of December. And so anybody who's interested, you know, do let us know if you can come, just because, you know, if for numbers reasons, you know, if we get a certain size, then we might try and get a little private space there. But we'll be at Spark Social SF, which is the outdoor beer garden food truck court right next to UCSF Mission Bay. And so, you know, easy to get to. It's outdoors, you know, so that we can still socialize in somewhat close quarters, and yeah, really looking forward to that. And that's that will probably be our you know, we'll be wrapping up for the year. I forget what is the 17th a. Sorry, let me just check what the. Okay, well, so I think the 16th will be our last.
Mm-hmm.
Then I will be on a plane. So unless I join you from Hawaii, that might be at our last meeting for the year.
Mm-hmm.
But other than that, yeah. Any last thoughts? Okay, Alex. Okay. Well, apparently, if we do meet, we'll all be joining from warm locations. Alex is saying Cancun. Okay. Good deal. All right. Take care, and I'll see you in a minute, Raphael.
All right. Thank you very much. Thank you so much for success.